Imagine this. Somewhere out there in the vast emptiness of space, there could be a place where time runs backward. Not a black hole that pulls everything in, but the exact opposite. A cosmic gate that throws matter out, with such violence that nothing can enter it, and whatever went in before is now being ejected back into the universe. Scientists call it a white hole. And we might have already seen signs of one, without even realizing it. But before we continue, subscribe to the channel so you don't miss any of these videos. See, everyone knows about black holes by now. They're in movies, they're in science books, they're basically pop culture at this point. They're places where gravity gets so intense that not even light can escape. But what's not as widely known is that, mathematically, the same equations that describe black holes also describe something else. Something we've barely scratched the surface of. A white hole. And this isn't science fiction. This is real math, real theory, and maybe, just maybe, real objects floating somewhere in the universe right now. But before we even get into what white holes really are, or how scientists came up with the idea, or why some people think they might actually be connected to the Big Bang itself, let's just sit with one wild idea. What if some of the weirdest things we've ever seen in space were white holes, not black holes? What if some of those massive bursts of unexplained energy, those fast radio bursts, those sudden gamma-ray flashes, weren't explosions, but openings? The reason white holes are such a mystery isn't just because they're hard to find. It's because they completely break the rules we're used to. They flip the script on what we think time and space should do. And if they're real, they don't just challenge our understanding of the universe, they blow it up completely. Let's take a step back. The idea of a white hole comes from Einstein's equations. Yeah, the same Einstein everyone talks about. When scientists ran the math backward on a black hole, they realized something strange. The exact equations that describe a black hole swallowing things could also describe the opposite, something that expels matter and energy, but can't be entered from the outside. It's like a one-way door in reverse. You can leave through it, but you can't walk into it. Now at first, this idea was mostly theoretical. People thought of it as a mathematical quirk, something that only exists on paper. But then, over the years, space started doing strange things. Bursts of energy that couldn't be explained. Objects that seemed to behave like black holes, but didn't act quite the same. And slowly, more scientists started asking, wait a minute, what if white holes aren't just theoretical? What if they're real? And here's the wildest part. There's a theory that says every black hole might eventually turn into a white hole. That the matter falling into black holes isn't just disappearing, it's being stored. And after enough time passes, maybe millions or billions of years, all that matter could come blasting out the other side. Not just somewhere else in space, but possibly in another time or another universe entirely. This isn't just random guesswork. Some scientists working on quantum gravity and loop theory, yeah, that's a real thing, believe that black holes don't end in singularities. Instead, they bounce. Like a trampoline. The matter hits a point of infinite density, then rebounds, exploding outward into a new form, a white hole. If that's true, then white holes could literally be the birthplaces of new universes. Or maybe even where our universe came from. Think about that for a second. The Big Bang is the biggest mystery in science. We know it happened. We know everything started from a point of insane energy and expansion. But we don't know what caused it. We don't know where it came from. What if it was just the other side of a black hole? What if the Big Bang wasn't the beginning of everything, but just a new chapter in a much bigger story? There are some people who think that black holes in our universe are actually portals. That they connect to other places, or even other universes. And when they collapse completely, they don't just vanish. They explode on the other side. That explosion is a white hole. And the Big Bang? Maybe that was the final moment of collapse of a massive black hole in another reality. Now, let's get into some of the candidate white holes. Because yes, we've actually seen things in space that might be them. Nobody's confirmed it yet, but the signs are weird. Take, for example, the mysterious object known as GRB 060614. That's a gamma-ray burst that lasted an unusually long time, 102 seconds, but it didn't match the behavior of a supernova or a black hole merger. It just kind of happened, then vanished. It didn't leave behind the right signals. No neutron star. No black hole. No collapsing star. Nothing. Some theorists suggested, maybe this was a white hole event. A sudden release of matter and energy from something outside our universe, or from deep within one. There are also fast radio bursts, FRBs. These are ultra-quick flashes of energy in the radio spectrum, sometimes lasting just milliseconds, but they come from deep space and they pack a punch. Some repeat, some don't. Some come from galaxies millions of light years away. Others just seem to pop up randomly. And nobody knows exactly what causes them. Could they be white holes blinking into our universe for just a moment? Maybe. Could they be evidence of matter being thrown out through some unknown process? It's possible. Another strange case was the 2022 detection of an object named J1745-2900. This was found near the supermassive black hole at the center of our galaxy. But it behaved differently. Its emissions didn't match what we expected. Some researchers speculated it could be some kind of exotic object, maybe even a white hole, though that's still just speculation. What makes white holes even weirder is that they seem to break the second law of thermodynamics. This law basically says that things tend toward disorder over time. Heat flows from hot to cold. Entropy increases. But white holes seem to eject matter and energy in a superorganized way, as if they were reversing entropy. That would make them incredibly strange, and possibly even hints that they exist in a different kind of time. Here's another idea. What if white holes are actually ancient? Like, older than galaxies? What if they're leftover from the very first moments of the universe? There's a theory called primordial white holes, which says that some of them could have formed during the Big Bang itself, and are still floating around today, either as tiny ultradense objects or huge bursts of energy that only activate under certain conditions. And we're just getting started. Something strange popped out. They found that for every black hole solution in Einstein's equations, there was another, mirrored solution, a white hole. Now, this wasn't just some math trick. It was a legit outcome of the same formulas that described gravity, space-time, and motion. But instead of sucking everything in like a black hole, this mirrored version did the exact opposite. It spat everything out. Permanently. No going in, no crossing the event horizon, just constant, unstoppable outward flow. At first, people didn't take this too seriously. I mean, how could something constantly push out matter and energy without ever taking anything in? That sounds completely opposite to how everything in the universe works, right? But as crazy as it sounds, this is what the math was saying. And the more physicists looked at it, the harder it became to ignore. Now here's where things get even weirder. A white hole isn't just a black hole in reverse. It might be the other side of a black hole. Think about it like this. If you fall into a black hole in one part of the universe, maybe you come out of a white hole in another part. Maybe even in another universe. That's right. This thing might not just be throwing stuff out randomly. It might actually be connected to something else through what some people call a wormhole. And that wormhole might be a shortcut through space, or even time. If that's true, then white holes aren't just rare, they're keys to something way bigger than we thought. Maybe even the structure of the universe itself. Let's talk about what would actually happen if a white hole existed in space right now. First, you wouldn't see it forming. White holes don't grow the way black holes do. They don't eat matter, they don't get heavier, and they don't pull stars in with their gravity. Instead, they push everything away. If you were flying a spaceship near one, you wouldn't get sucked in, you'd get pushed out fast. You'd be repelled so violently that getting close would be nearly impossible. Now here's the mind bender. Some scientists think we might have already seen a white hole, and we just didn't realize it. One of the big ideas floating around is that a white hole could look like a gamma ray burst. These are short, insanely bright flashes of energy that come from deep space. They last only a few seconds, but they release more energy than the sun will in its entire lifetime. And the wild part? We still don't really know what causes some of them. They don't always match up with supernovae or other events we can explain. So some researchers started asking, what if these bursts are the signatures of white holes opening and then vanishing? Imagine that. You're a telescope operator, and one day you pick up a sudden, blinding flash of energy from a place in the sky that looked totally normal a moment ago. Then, just as quickly it's gone. No warning, no pattern, no repeat. Just a sudden appearance, and disappearance, of something enormous. That's exactly what you'd expect if a white hole popped into existence, dumped its contents into space, and then collapsed or faded. And it gets crazier. There's another idea that maybe our entire universe started as a white hole. You heard that right. The Big Bang itself, this thing that created space, time, matter, everything, might have been a white hole. According to this theory, we're living inside the result of that explosion. Some physicists even call it the Big Bounce theory. The idea is that our universe came from the collapse of a previous one, which shrank into a black hole, and that black hole then transformed into a white hole, blasting out a new universe. Ours. That means the universe we know, all the stars, planets, galaxies, could just be the debris field of some ancient white hole on a cosmic scale we can't even comprehend. And the Big Bang? That wasn't the start of everything. It was just the middle of something bigger. Let's take a second to break down why this is such a massive deal. If white holes are real, they completely destroy the idea that black holes are the end of the line. Right now, we think black holes are where things go to die. Matter, information, time, it all disappears behind the event horizon. But if white holes exist, then nothing ever truly disappears. It just comes out somewhere else. Maybe even someone else. And this connects to something even deeper, the black hole information paradox. This is one of the biggest mysteries in all of physics. It's the question of whether information is truly lost inside a black hole. According to quantum mechanics, that shouldn't be possible. Information can't just vanish. But according to general relativity, it does. These two laws are fighting with each other. But if black holes have white hole twins, then the information isn't lost. It's just waiting to be spit out later. That would fix the paradox. That would mean the universe is still playing by the rules. Just in a really bizarre way. But now let's talk about the white hole candidates, the ones scientists think might actually exist. The most talked about candidate is called GRB 060614. It was a long-duration gamma-ray burst, but weirdly, it didn't come from a supernova like we expected. Usually, long bursts mean a massive star died and exploded. But with this one? Nothing. No sign of a supernova. Just a blast of energy out of nowhere. Some scientists said this might be what a white hole looks like in action, a short, sudden appearance, dumping mass and energy into space, and then vanishing. Another possible candidate is the mysterious object at the center of our galaxy. We usually think it's a supermassive black hole, right? But what if it's not a black hole? What if it's something else? A hybrid object. Something that looks like a black hole from far away, but inside, it's doing something we don't understand. Maybe it's oscillating. Maybe it's leaking. Maybe it's the other end of a tunnel we haven't found yet. Now here's a twist. Some theoretical physicists believe black holes themselves might become white holes. Over time. This isn't science fiction. This is loop quantum gravity, a field of physics that tries to combine Einstein's theory of gravity with quantum mechanics. According to this theory, when a black hole gets small enough, like smaller than an atom, it bounces. It stops collapsing and starts expanding again, like a spring uncoiling. And that expansion? That's a white hole being born. Slowly at first. Then explosively. That means every black hole in the universe might eventually turn into a white hole. It might take billions of years, but it'll happen. So maybe white holes aren't rare. Maybe they're just slow. Maybe they're everywhere, but sleeping. Think about what that means. In the far future, the black holes we see today might start waking up. Not to eat more matter, but to spit it all back out. The universe could become filled with the echoes of its own past. The ghosts of what used to be, returning in a new form. That's not just poetic. That's a real scientific possibility. And it goes even deeper. Some researchers think white holes could help explain dark matter. That strange, invisible stuff that makes up most of the mass in the universe, but doesn't interact with light? We've never seen it directly. But some people think white holes might be hiding in plain sight as chunks of dark matter. They wouldn't look like normal matter. They wouldn't behave like stars or gas clouds. But they'd have mass. They'd bend light. They'd clump together. Just like dark matter does. And if white holes are the long-dead remains of black holes from an earlier era of the universe, then maybe we're surrounded by ancient ghosts. White hole remnants we can't even detect. We're just scratching the surface here. Powerful flashes of energy that suddenly appear in the sky, last a few seconds or minutes, and then vanish like nothing ever happened. They come from deep space, and they release more energy in that short time than our sun will emit in its entire lifetime. For years, astronomers thought gamma-ray bursts came from collapsing stars or merging neutron stars. And yeah, a lot of them probably do. But not all. Some of these bursts are just too strange. Too short. Too sudden. Too unexplained. That's where white holes come in. There's a theory that some of these bursts might actually be white holes appearing in space. Imagine it, a spot in the universe suddenly erupts, throwing out matter and energy that's been locked away somewhere else. Or maybe someone else, and then just disappears again. Like a cosmic sneeze. Boom. Gone. That's exactly what a white hole would do. It would show up, spit everything out, and then vanish. But here's where it gets even more mind-twisting. Some physicists think white holes don't even last. They might pop into existence for a tiny fraction of a second, dump their contents into space, and then blink out again. Like the universe is randomly coughing up pieces of itself. And the wildest part? Some believe the Big Bang itself might have been a white hole. That's right. The very beginning of our universe, the moment everything exploded into being, could have been a white hole event. That would mean our entire universe came out of one. Just imagine that. We're not just floating in space, we might be inside a white hole. Now you might be thinking, if this is all possible, why haven't we seen more of them? Why don't we spot white holes all the time? Well, part of the reason is that they're incredibly hard to detect. A black hole leaves behind signs, stars orbiting weirdly, X-rays being emitted from heated material as it spirals in, gravitational lensing, things we can see with our telescopes. But a white hole? It just appears, dumps its payload, and disappears. It doesn't hang around. It doesn't give us time to study it. And if it does give off any light or radiation, it's over before we even know it started. Now here's where things go even deeper. Let's talk about time. In black holes, time slows down the closer you get to the event horizon. To someone watching from far away, anything falling into a black hole seems to slow down, freeze, and then fade. But inside, time keeps going. That's because the gravity's so intense, it actually warps time itself. Now flip that idea. In a white hole, time would flow in the other direction. You'd be pushed out faster and faster. Time wouldn't slow down, it would speed up. And nothing could go back in. Once something comes out of a white hole, it's gone. It can't return. It's like a one-way street through time and space. There's also something super weird that people talk about when it comes to white holes, and that's information. One of the biggest problems with black holes is something called the information paradox. Basically, when something falls into a black hole, all the information about it seems to vanish forever. And that breaks the rules of quantum mechanics, which says information can't be destroyed. So scientists have been arguing about this for decades. But here's one idea. What if the information doesn't vanish? What if it's just moved? What if everything that falls into a black hole eventually gets spit out through a white hole? This brings us to something really wild. Black holes and white holes might not just be connected. They might be the same object, just at different points in time. Some people call this a Planck star. It's the idea that after a black hole reaches a certain tiny size, it stops collapsing and then rebounds. It becomes a white hole. So maybe every black hole in the universe is actually a white hole waiting to happen. It's just taking a long time, maybe even billions of years. There's a theory from loop quantum gravity, a model of physics that tries to connect quantum mechanics with general relativity, that says this kind of bounce is possible. According to it, space isn't smooth and continuous like we usually think. It's made of tiny loops, like a woven fabric. And when matter gets compressed to an insane degree, like inside a black hole, it can't collapse forever. Eventually it hits a limit and bounces back. And that bounce? That's a white hole forming. So a black hole dies, and a white hole is born. Think about what that means. Somewhere out there, a black hole could be getting ready to transform into a white hole. And when it does, everything that ever fell in could come blasting out into space. Planets, stars, gas, light, even information, all flying out, rewritten by time and gravity. And if that white hole is in another universe, or another dimension entirely, then it might mean something, or someone, on the other side gets to see what our universe once was. Now, let's come back to reality for a second. There are some white hole candidates out there, objects we've seen that don't quite make sense. Things that don't match up with black holes or stars or galaxies. One of the most famous is GRB 060614. It was a gamma-ray burst that lasted way too long to be a regular burst, but it didn't come from a supernova either. It confused scientists for years. Some said it must be two neutron stars colliding. Others said maybe it was something totally new. But one theory quietly suggested, maybe it was a white hole. Another weird object was found with strange gravitational effects, but no light, no heat, no material around it. It acted like a black hole, but not quite. Some scientists believe this could be a white hole candidate, one of the few times we've actually caught one in the act. But without more evidence, it's hard to say. Because remember, these things don't stick around. They're flashes in the dark. You see them or you don't. But here's a question that keeps coming up. If white holes are real, where are they all hiding? One possible answer is that they don't last long enough for us to find. Another is that they only form under extreme conditions, like the birth of a universe. And maybe that's the point. Maybe white holes aren't just rare, they're cosmic beginnings. Not the end of matter, but the start of something new. And then there's this, what if white holes are all around us, but we can't see them because we're inside one? If our universe really did come out of a white hole, then from the outside someone, or something, might see our whole universe as a white hole explosion. That's a crazy idea, but it fits with some models of cosmology. It means that the Big Bang wasn't the start of everything. It was just a transition. A bounce. An eruption of something that used to be somewhere else. And now, we're living inside the echo. About the math and physics behind white holes. Don't worry, I won't get all technical and start throwing equations at you, but it helps to understand the basics of how these ideas came up in the first place. So, Einstein's general theory of relativity tells us how gravity works, not just like a force, but like a warping of space and time. Massive objects like stars and planets bend the fabric of space, and that bending is what we feel as gravity. It's like putting a bowling ball on a trampoline. Everything rolls toward it. Black holes take this to the extreme. They're places where so much mass is packed into such a small space that the bending becomes infinite. Nothing can escape. Now here's where it gets trippy. When scientists started solving Einstein's equations for these kinds of conditions, they found something called the Schwarzschild solution. This describes a non-rotating black hole, and hidden inside that solution was a surprise, a second region, mathematically valid, that behaves like the mirror image of a black hole. A white hole. It wasn't just a random part of the math either. It actually made sense in the context of relativity. But here's the catch. While black holes can form from real processes we've seen, like stars collapsing under their own weight, there's no obvious natural process that makes a white hole. You can't just reverse time and expect a white hole to form. At least, not in any way we understand yet. And that's where a lot of physicists get stuck. Because for white holes to be real, they need a way to come into existence that fits the laws of physics. And unless we're missing something huge, that's a pretty big hurdle. But not everyone agrees. Some scientists believe white holes could exist as part of quantum gravity, a theory that combines quantum mechanics, which rules over the tiny stuff like atoms, with general relativity, which rules over the big stuff like planets and stars. One of the leading ideas in this area comes from something called loop quantum gravity. It's a wild theory that tries to describe space itself as being made up of tiny loops, like a woven fabric. In this theory, when a black hole collapses, it doesn't end in a singularity, an infinite point. Instead, the collapse eventually bounces back. It turns into a white hole. So black holes might not be the end. They might just be the first half of a process. Imagine it like this: you fall into a black hole, and for you, it's game over. But on a cosmic timescale, billions or trillions of years, that black hole could shrink, fade, and then explode outward as a white hole. Everything it swallowed would come back out. Not where it went in. Not even when it went in. Just back out. Somewhere. Somewhen. It's the ultimate cosmic recycling. This idea has huge consequences. If it's true, then the universe has a built-in way to avoid permanent destruction. Nothing stays lost forever. Everything comes back. Eventually. But wait, it gets even more insane. What if some of the weird objects we've already found in space aren't black holes at all, but white holes? Some astronomers have observed regions of space where massive amounts of energy are being released without a clear source. There are fast radio bursts, or FRBs, brief, millisecond-long blips of powerful radio waves from distant galaxies. They're bright, they're short, and they often repeat. We still don't know what causes them. Some think it's magnet stars or neutron stars. Others say, maybe white holes. And then there's the Great Attractor. It's this mysterious point in space that's pulling entire galaxies toward it. We can't see it clearly because it's behind the Milky Way's thick core, but we can measure its gravitational effects. Something is pulling on everything in that region. Could it be the aftermath of a white hole? Could it be something more bizarre? Then there's dark matter and dark energy. We know they're out there. We can measure their effects. But we can't see them, touch them, or explain them. What if white holes are tied to that? What if every time a white hole appears and releases something, it adds a little more of that invisible stuff into the universe? What if white holes are responsible for some of the energy and mass that we just can't account for? All of this might sound like science fiction, but remember, black holes sounded like fiction too. When Einstein first came up with them, even he didn't believe they were real. It took decades of evidence and observation before the scientific community accepted them. And now, they're an everyday part of how we understand the universe. White holes might be on that same path. Unbelievable today. Unavoidable tomorrow. And here's something even scarier to think about. If white holes exist, what if they're not stable? What if they don't just spit out some matter and vanish? What if they keep growing in strength? What if a white hole appeared near our galaxy and started dumping mass into space? It would distort everything around it. Space. Time. Gravity. Light. It could tear planets from their orbits. It could stretch space-time itself. It could be the most dangerous thing in the universe, and we wouldn't even see it coming. Or maybe it already came. Maybe the stuff we see drifting in deep space, the strange clouds of high-energy particles, the radiation storms, maybe those are all echoes of ancient white holes. Ones that appeared billions of years ago and are still reshaping the universe today. The truth is, we just don't know. But the idea is growing. More and more scientists are taking white holes seriously. They're writing papers, running simulations, and trying to match the theory with what we actually see in space. Because the clues are there. They're faint, they're weird, but they're there. And they're pointing to something stranger than we've ever imagined. And everything that got crushed into the black hole doesn't stay gone forever. It comes bursting out the other side. This is called a black-to-white hole transition. And it could mean that black holes aren't just the end of matter, they're part of a recycling process. Matter and energy go in, they get squeezed and scrambled beyond recognition, and then maybe, just maybe, they explode back out from a white hole somewhere else in the universe, or even in a different universe altogether. Now pause for a second and really think about what that means. That would make white holes not just weird cosmic objects, but gateways. Gateways to the other side of a black hole. Gateways to lost information. Maybe even gateways to other realms of reality. And this isn't just sci-fi talk. These are serious ideas being explored by real physicists right now. But there's another angle to this whole mystery, and it has to do with something called the information paradox. Here's the deal. According to quantum physics, information, like what something is made of, how it behaves, what state it's in, can't be destroyed. Ever. But black holes seem to break that rule. When something falls into a black hole, it disappears beyond the event horizon, and we can't see it anymore. Eventually, the black hole might evaporate due to something called Hawking radiation, and when it does, all that stuff that went in, gone. Erased. That's a huge problem, because it means either our understanding of black holes is wrong, or our understanding of quantum mechanics is wrong. And both are kind of important. Enter white holes. Some theorists believe that if black holes eventually become white holes, if everything they swallowed gets blasted back out later, then maybe information isn't lost. Maybe it just takes a really, really long time to come back. Maybe trillions of years. But it comes back. That would mean white holes solve one of the deepest mysteries in physics. And here's something even more intense. What if a white hole is already inside every black hole? What if, instead of dying in a singularity, everything that falls into a black hole is actually feeding into a white hole waiting to form on the other end? A kind of cosmic tunnel. A birth and a death, connected by the most extreme forces in the universe. Let's break this down even more, because it's important to grasp just how strange and exciting this is. Universe. That would mean every black hole isn't just a grave, it's a womb. A place where matter goes to be crushed, reorganized, and eventually released through a white hole into a different region of space-time. Now think about this. If that's true, then maybe the universe isn't expanding from one big bang, but from countless smaller bangs. Maybe every time a white hole appears, it's the birth of a new region of space. A new baby universe. That leads us to a mind-blowing idea called the multiverse theory. According to this theory, our universe might just be one of many, and white holes could be the portals connecting them. In other words, every black hole in our universe might be a link to a new universe created through a white hole on the other side. It's not just theoretical fantasy either. Some of the math supports this as a real possibility. But we're still not done. Because here's where things get seriously creepy. We might have already seen white holes without even realizing it. Back in 2006, a strange cosmic event was detected by NASA's SWIFT satellite. It was a gamma-ray burst that didn't fit any known category. It didn't behave like the ones caused by dying stars or neutron-star collisions. It came out of nowhere, flashed brightly, and then vanished. No warning. No afterglow. Nothing. Some scientists called it a short GRB with no host galaxy. But a small group of physicists proposed something different. It might have been a white hole. A real one. A white hole candidate, showing itself for just a moment before disappearing. And this isn't the only strange flash we've seen. There are dozens of unexplained high-energy events recorded by our satellites and observatories. Some come from areas with no nearby galaxies. Some are so short-lived we barely catch them in time. Could these be white holes? We don't know for sure. But they don't fit neatly into any other category, and that's why the idea is gaining attention. Now let's talk about time. Time works differently near a black hole. The closer you get to the event horizon, the slower time moves for you compared to someone farther away. That's just how gravity and time interact. So if a white hole is the reverse of a black hole, would time move faster near one? Would you see the entire life of the white hole happen in an instant? Would it age billions of years in just a few seconds? Or maybe it would spit out things that have been frozen in time for eons. Maybe things from the beginning of the universe, or even before. And here's another twist. Some scientists suggest that if we ever did find a stable white hole, and if we could somehow survive near it, we might be able to see the past. Not time travel, exactly, but glimpses into other eras through whatever the white hole ejects. Think about that: fossils of the cosmos, ancient material that's been locked away since before Earth even formed, suddenly thrown into space like forgotten treasure. What would we find? We might find matter that's older than our universe. Atoms that formed in a completely different space-time. Particles that don't obey our rules of physics. Maybe even evidence of civilizations we've never heard of, beings that lived in a universe before ours, and left something behind. It sounds insane, but if white holes are real, then all bets are off. But we're still left with a big question: how would we know for sure? To confirm the existence of white holes, we need to catch one in the act. We need to see a burst of energy that matches the predictions: no precursor star, no merging objects, no gravitational waves, just a sudden, explosive appearance of matter and light. And even then, it would be hard to rule out every other explanation. But scientists are working on this. New telescopes, like the James Webb Space Telescope and others being planned for the future, are built to catch fainter, older, more distant signals. We're looking deeper into space than ever before, and maybe, just maybe, we'll catch a white hole live on camera. And if we do, it could change everything. Because then we'd know for sure that the universe isn't just one way. It's not just about collapse and endings. It's also about reversals and rebirths. White holes would become a symbol of hope, a message from the universe that nothing is ever truly gone. That everything can come back, even after disappearing into the darkest places. And maybe, just maybe, understanding white holes could help us understand something else: what happens after death. Not just physical death, but cosmic death. What happens when a galaxy dies? Or when the universe dies? Is there a white hole waiting at the end of time, ready to recycle everything and begin again? There's no answer yet. But we're getting closer. Would everything get pushed away from the white hole so quickly that time seems to race forward the closer you get? That's one idea, but the truth is, we don't really know. The math says white holes would behave like time-reverse black holes, but when you try to make sense of that in the real universe, where things don't run backward, it gets weird fast. But let's go even deeper. Some physicists believe that white holes might actually be hiding in plain sight, not just as random cosmic flashes, but as something even stranger: dark matter. You've probably heard of dark matter, right? It's this mysterious stuff that makes up most of the matter in the universe, but we can't see it. We only know it's there because of how it affects gravity. Galaxies spin faster than they should if they were just made of normal matter. There has to be something else out there, an invisible mass that holds everything together. Now, here's the twist: what if white holes are dark matter? Not directly, but maybe white holes are extremely old black holes that made the transition. Some researchers have proposed the idea of Planck stars, tiny, dense remnants of black holes that have turned into white holes but are so small and cold that we can't detect them easily. They would just float through the galaxy, invisible, silent, and eternal. These Planck-scale white holes could explain part of the dark matter mystery. They'd be everywhere, just not interacting with light or regular matter, except through gravity. And there's more. There's a possibility that some of the most ancient white holes could be leftovers from the very beginning of the universe. Think about it. If the universe began with a Big Bang, and if that was like a giant white hole event, then smaller white holes could have formed right after, scattered like seeds throughout the early cosmos. Some may have evaporated. Some may have collapsed into black holes. And some may still be out there, hidden in the darkness between stars and galaxies, waiting to be discovered. But here's the wildest part of all this: white holes challenge our entire understanding of reality. They don't just mess with gravity and time, they mess with causality itself. In our everyday world, things happen in a sequence. Cause comes before effect. You drop a glass, it shatters. But with a white hole, it's like the effect comes before the cause. Something appears, matter, energy, without anything falling in to cause it. It's like a firework that explodes in space for no reason. That breaks every rule we're used to. And yet, if black holes exist, and we've seen them, then their mirror image must also exist, at least on paper. Nature tends to be symmetrical, and physics is full of these mirror image relationships. For every particle, there's an antiparticle. For every positive charge, there's a negative. So why not for black holes? Of course, just because something can exist in the equations doesn't mean it does exist in reality. But history shows that physics equations often predict things before we find them. Neutrinos were predicted long before we built detectors powerful enough to spot them. The Higgs boson was a ghost in the math for decades before we confirmed it. So maybe white holes are the next ghost to be caught. Maybe we just haven't built the right instruments yet. Still, even without direct evidence, white holes offer an answer to one of the scariest questions in physics: what happens to information? If white holes are real, they could be the exit door. Not just for matter and energy, but for knowledge, for the details of what fell into a black hole. That would save quantum physics. It would also mean that nothing is ever truly lost. That every book, every atom, every thought that fell into a black hole might someday come back out, through a white hole, somewhere in the infinite vastness of space. You press a button, then the elevator comes. Cause and effect, it's the foundation of how we experience life. But white holes might flip that logic inside out. If they are truly the time-reverse version of black holes, then they don't have a cause, in the normal sense. They could just appear, suddenly eject matter and energy, and vanish, without anything triggering them. In other words, their effect might come before their cause. And that breaks every rule we use to understand the universe. If something can exist without being caused, if matter can erupt from nothing, then the entire idea of predictable physics starts to unravel. This isn't just a scientific curiosity, it's a philosophical nightmare. It forces us to ask, what does before and after even mean near these objects? And if causality can break down around white holes, where else might it fail? Now let's return to those gamma ray bursts we talked about earlier. Some of them come from places in the sky where we see no galaxies, just emptiness. No stars, no clusters, no nebulae, just deep, dark space. And yet, something out there is producing energy so intense that it outshines entire galaxies for a few seconds. If these bursts were just rare types of supernovae or neutron star mergers, we'd expect to see a host galaxy. But in several cases, we don't. That's why some astrophysicists have started cataloging these events as potential white hole candidates. It's controversial, and there's a lot of skepticism, but it's also hard to ignore the strangeness. These flashes don't fit the patterns we know. They don't behave like any known object, and they often lack the afterglow we expect from explosions in space. That's why they've been labeled unclassified transients. Maybe one day, we'll look back and realize we were watching white holes all along. And here's where we go even deeper, into the math behind it all. Einstein's general relativity allows white holes. If you take the equations that describe a black hole in reverse time, you get a solution that describes a white hole. It's called the Schwarzschild solution. The only problem? It's a mathematical object, not a physical one, at least as far as we know. You can write it down, you can graph it, and you can model it in simulations. But so far, nobody's been able to prove that white holes must exist in our universe. They're a valid answer to Einstein's equations, but the universe doesn't always follow the math. Sometimes, it chooses a different path. That said, some of the brightest minds in theoretical physics, like Carlo Rovelli and Hal Haggard, believe that white holes do exist. They've developed models where black holes eventually bounce, turning into white holes once quantum gravity effects become dominant. And this is where things get really intense: quantum gravity. It's the one thing we still haven't figured out. We have general relativity, which explains gravity and the behavior of large objects like stars, planets, and black holes. And we have quantum mechanics, which explains the behavior of tiny particles. But the two theories don't get along. Black holes are where those two theories crash into each other. And maybe, just maybe, white holes are the result of that collision. Quantum gravity theories like loop quantum gravity suggest that when matter collapses into a black hole, it doesn't form a singularity. Instead, it gets compressed to a minimum volume and then bounces outward, becoming a white hole. In that model, the black hole never fully dies. It just transforms. That's not just fascinating, it's revolutionary. Because if that's true, then everything we thought we knew about death in the universe changes. Stars don't just die and leave behind frozen remnants. Galaxies don't just collapse into nothing. Even black holes don't mark the end. There's always a next stage. A rebirth. That would mean the universe isn't built on endings, but on transitions. One state becoming another, again and again, forever. As we know right now. In the Schwarzschild solution, the white hole is just the time reverse of a black hole, meaning everything that goes into the event horizon of a black hole in one direction is exactly mirrored by stuff coming out of the event horizon of a white hole in the other direction. But when you plug that into the real universe, it starts to fall apart. Why? Because time doesn't actually reverse itself. In the real universe, entropy always increases. Things decay. Systems get messier, not cleaner. That's why you never see shattered glass spontaneously reassemble, or smoke gather back into a cigarette. So if a white hole is truly a reverse-time black hole, it would violate the second law of thermodynamics. It would be something so strange, so fundamentally unnatural, that the universe might not even allow it. And yet, the math keeps saying it's possible. And sometimes, in physics, the math knows more than we do. But there's another twist: quantum gravity. When we try to combine quantum mechanics with general relativity, we start to get new possibilities. One of them is that black holes don't last forever. They slowly lose mass through Hawking radiation, a process predicted by Stephen Hawking. Over billions of years, they shrink. And just before they disappear completely, some theories suggest they might explode in a final burst of energy. But other theories suggest something different: they might bounce. Instead of vanishing, a collapsing black hole might hit a quantum limit at the Planck scale, the tiniest scale of existence, and then rebound outward, not as a black hole, but as a white hole. This bounce idea comes from loop quantum gravity, one of the main contenders for a theory of everything. If that's true, then white holes are not just theoretical, they're inevitable. Every black hole would eventually turn into one, given enough time. And because time near a black hole moves so slowly for the matter falling in, what looks like billions of years from the outside might be just a flash on the inside. So from our perspective, white holes could be appearing right now, even if they're the end result of a process that started eons ago. And this ties back to the Big Bounce model of the universe. In this model, the universe didn't start with the Big Bang out of nothing. Instead, it was collapsing before, and that collapse reversed in a giant bounce. That bounce could be thought of as a universe-sized white hole. Matter compressed to its limit, then rebounded into a new phase, our current universe. If white holes can form from collapsing matter, then the universe itself might be one giant white hole. That would mean our entire reality, everything we see and touch, everything we know, came spewing out of one massive time-reverse singularity. And if that's true, then what lies beyond our universe might be just as real: previous universes, collapsed ones, or entirely different ones that formed from other white holes. But here's a practical question: why haven't we seen more direct signs of white holes if they really exist? The answer might be simple: they don't last long. Theoretical models suggest that white holes would be incredibly unstable. The moment matter approaches them, their structure could collapse. Unlike black holes, which are stabilized by gravity pulling inward, white holes are constantly ejecting stuff outward. That makes them fundamentally fragile. The instant anything disturbs their flow, say, by getting too close or trying to fall in, the system breaks down. So even if they do form, they might collapse into regular black holes again almost instantly. That could explain why we've only seen a handful of mysterious flashes that might be white holes. They're like cosmic hiccups, real, but fleeting. And let's not forget the speculative stuff, the part that science fiction loves to play with. If white holes are real, and if they connect to black holes, then in theory, They could be part of a wormhole system. That means you could fall into a black hole in one place and come out of a white hole somewhere else. Maybe in another galaxy. Maybe in another universe. Maybe even in another timeline. Now, this is way beyond proven science, but the idea is so tempting that physicists have explored it seriously. Kip Thorne, one of the world's top physicists and a Nobel Prize winner, worked on these ideas decades ago. The catch is that most wormhole models require exotic matter, stuff with negative energy density, to keep them stable. We haven't found anything like that yet. But that hasn't stopped scientists from dreaming. Because if we ever do find a working white hole, one that lasts, one that's real, it might be the key to faster-than-light travel, time travel, or exploring other dimensions. And even if none of those dreams come true, white holes still matter. Because they stretch our imagination. They force us to test the limits of physics. They ask questions no one else is asking. What happens when you reverse time? What's on the other side of a black hole? What's the universe hiding in those brief, strange flashes we don't understand? The search for white holes isn't just about exotic objects in space. It's about testing the very rules that shape our reality. It's about going to the edge of what we know, and then stepping past it. Instead of ending in a singularity, it bounced back outward in what we call the Big Bang. That bounce, from a collapsed state into an expanding one, is eerily similar to what loop quantum gravity suggests for black holes turning into white holes. So, in a sense, the birth of our universe could itself be thought of as a kind of white hole event, a release of all the matter, energy, and space that had previously collapsed. And if the universe can do that once, who's to say it doesn't happen on smaller scales too? Maybe every black hole is the seed of a new universe. Maybe inside each black hole is an expanding cosmos that looks just like ours did 13.8 billion years ago. That would mean our universe could be the inside of a black hole from some larger, parent universe. And what we perceive as black holes in our sky might be gateways to other universes, with white holes forming on the other side. It's a radical idea, but it solves a lot of problems, like the information paradox, the arrow of time, and even the fine-tuning of cosmic constants. Let's pause and look at what a white hole would actually look like if we saw one. It wouldn't be like a star. It wouldn't shine continuously. It would erupt. A sudden blast of energy, maybe followed by a stream of particles, radiation, or even antimatter. It wouldn't have an accretion disk, because matter can't approach it. It's constantly pushing everything away. If a spacecraft got close to it, it would be pushed back violently. The closer it got, the more intense the radiation and pressure would be. You'd never see anything falling into it, because nothing can. It would be a glowing scar in the sky, surrounded by emptiness. And then, as suddenly as it appeared, it could disappear again, burning out like a match. The sheer strangeness of it would be unmistakable. That's why some scientists believe we might already have seen them, but didn't recognize them because we weren't looking for something so different. We have to talk about white hole stability though, because this is one of the biggest reasons scientists have doubted their existence. In the equations of general relativity, white holes are unstable. Any little disturbance, gravity, particles, radiation, should be enough to collapse the white hole into a black hole. It's almost like the universe doesn't allow them to survive for long. If a white hole is even slightly disturbed, it gets overwhelmed by the pressure of incoming matter and collapses inward. So how could one exist at all? That's where quantum effects might save the day. In loop quantum gravity and other quantum gravity theories, there are suggestions that space-time itself becomes repulsive at very small scales. That repulsion could be strong enough to resist collapse, allowing a white hole to survive, at least temporarily. It would be brief, but real. And in that brief flash, we might witness the birth of something entirely new. One more fascinating idea? White holes might be time travelers. Not literally, like stepping into a DeLorean, but in the sense that they might eject matter from the past into the present. If a white hole is the end point of a black hole that collapsed billions of years ago, then the matter it ejects is ancient. It could carry information from the early universe. It could even include particles that have been bouncing around the event horizon for eons. So observing a white hole might be like opening a time capsule from the dawn of the universe. But the weirdest part? We wouldn't know where it came from. The information might be preserved, but the location would be erased. It's like getting a package with no return address, but inside is something from 10 billion years ago. There are even speculations that white holes could play a role in dark matter. Dark matter is this invisible stuff that makes up most of the mass in the universe, but we can't see it, touch it, or detect it directly. It only reveals itself through gravity. And some researchers have proposed that primordial black holes, tiny black holes formed in the early universe, could make up dark matter. But others have taken it further. What if dark matter is made up of stable white hole remnants? If black holes can bounce and become white holes, and if those white holes don't immediately vanish, they might just hang around in space, invisible, not interacting with light. They would have mass, they would have gravity, and they would be scattered throughout the universe. That sounds an awful lot like dark matter. It's speculative, yes, but it's testable. If we can find a way to detect such remnants, it might solve one of the biggest mysteries in cosmology. Here's something else wild. White holes might not just be part of a black hole's future. They might be part of its present. In some models of spacetime, a black hole and a white hole aren't separate objects, but two sides of the same thing. You fall into a black hole and emerge from a white hole somewhere else, or someone else. Maybe in another universe. Maybe in our own, but in the distant future. This ties into the concept of an Einstein-Rosen bridge, a kind of wormhole. Normally, wormholes are unstable, but if the black hole becomes a white hole, it could stabilize the tunnel. That means traveling through a black hole might not be a one-way trip into destruction. It might be a passageway to another region of spacetime. Of course, the odds of surviving that trip are basically zero with our current understanding. But again, the math says it might be possible. There are scientists right now working on white hole simulations. They're using supercomputers to model how black holes collapse, what happens at the Planck scale, and whether a bounce is physically consistent. It's not just imagination, it's code, it's equations, it's real data. And while we haven't observed a white hole yet, the idea is becoming less fringe and more mainstream. Major institutions, like CERN and NASA-affiliated research centers, are funding theoretical work on these ideas. They're exploring how white holes could fit into the puzzle of quantum gravity. And more importantly, they're figuring out how we might test for them. That's the Holy Grail, an experiment. A way to confirm or deny whether white holes exist. Maybe it's a signature in a gravitational wave. Maybe it's a gamma-ray burst with no afterglow. Maybe it's an anomaly in the cosmic microwave background. But make no mistake, people are looking. Some researchers are even proposing that white holes might create what are known as firewalls, violent boundaries that burn up anything trying to enter a black hole. This would solve the information paradox, a long-standing problem in physics. Right now, we don't know what happens to information when it falls into a black hole. Quantum mechanics says information can't be destroyed. But black holes seem to destroy it. If black holes turn into white holes, and eject that information later, the paradox goes away. The firewall is the barrier that forms to protect the information, so it doesn't fall into the singularity. But if firewalls are real, they would radically change how we think about spacetime. They would be like walls of pure energy, separating regions of space and time. Crossing them would be fatal, but staying outside would reveal secrets. Another mystery tied to white holes is entropy. Black holes have entropy, the measure of disorder in a system. The larger the black hole, the more entropy it has. But what about white holes? If they're time reversed, shouldn't they have negative entropy? That would break the laws of thermodynamics. So maybe entropy flows differently near a white hole. Maybe it decreases locally but increases globally. That would be a major revision of how we think the universe works. It would mean that time and thermodynamics can bend near extreme objects. That's not something we're used to, but it might be real. One of the biggest conceptual challenges in physics is unifying general relativity with quantum mechanics. These two theories describe different parts of the universe, and they don't get along. White holes might be the bridge between them. They involve gravity, space-time, energy, and quantum behavior, all in one object. If we can understand them, we might finally unify the laws of the universe. That's why this isn't just a curiosity, it's a possible key to everything. Dark energy, dark matter, black holes, the Big Bang, the arrow of time, they might all connect through white holes. We just need the courage to keep digging, even when the answers seem impossible. Think of it like a balloon being blown up to the absolute limit, one tiny poke and it pops. In the case of white holes, the very space around them is their weakness. They repel matter, yes, but they also have to exist in a universe filled with matter, and even a single atom heading toward them could theoretically cause them to collapse. This is one reason why many physicists think white holes, if they exist, can only appear in very specific, very isolated conditions, like right after the Big Bang, or in the distant future where black holes might bounce after shrinking to a critical size. But others argue that the bounce process itself might somehow protect them. That the quantum geometry of spacetime at ultra-small scales might create a kind of buffer that prevents the white hole from collapsing as quickly as we think. This leads us to the idea of Planck stars. These are hypothetical objects that form when a collapsing star reaches Planck density and can't collapse any further. Instead of becoming a singularity, a point of infinite density, it becomes something else, a compact object that's still unimaginably dense, but not infinitely so. Then, after a long enough period of time, it bounces outward and becomes a white hole. Some researchers believe this entire transition could take place inside a black hole, hidden by its event horizon. To the outside universe, it might look like the black hole is just sitting there, slowly evaporating. But inside, everything that fell in might already be in the process of rebounding. And when the black hole finally evaporates, the white hole emerges in a flash. What we see as a sudden disappearance of a black hole might actually be the final step of a hidden transformation. It's here that we get to one of the most mind-bending parts of the white hole theory, the idea of black hole-white hole tunnels. These tunnels would essentially be wormholes, or Einstein-Rosen bridges. One side is a black hole, pulling in matter and energy. The other side is a white hole, spewing it back out. These wormholes could connect different regions of our universe, or entirely different universes altogether. And while the classical version of wormholes collapses too fast to travel through, some quantum models suggest they could be stable for brief periods, especially if exotic matter is involved, matter with negative energy density. We haven't discovered exotic matter yet, but it's allowed by the equations of quantum field theory. If it exists, even in tiny amounts, it could theoretically keep a wormhole open long enough for something, light, particles, maybe even information, to travel through. The problem is, we've never observed a wormhole or a white hole directly. But that doesn't mean the evidence isn't out there. Some astrophysicists think certain unexplained cosmic events might actually be white holes. One candidate? Gamma-ray bursts. These are some of the brightest, most energetic flashes in the universe. They last from milliseconds to minutes and can outshine entire galaxies. Most are believed to come from supernovae or merging neutron stars. But some don't fit those models. They come from regions with no nearby stars. They happen suddenly and disappear without a trace. Could they be white holes? Could we be seeing, in real time, the universe spitting out matter and energy from another dimension, or from the deep past of a black hole that just reached its bounce point? It's speculative, but that's what makes it thrilling. And then there's the cosmic microwave background, the faint afterglow of the Big Bang. Some scientists are looking for white hole signatures buried within it. If the Big Bang itself was a white hole-like event, then the fingerprints might still be there. Unusual patterns, tiny fluctuations, or unexpected anisotropies in the background radiation could all be signs of white hole activity. We already know the early universe was extremely hot and dense, and that it expanded rapidly. But why did it expand in the first place? What pushed it outward? Standard cosmology says it was inflation, a period of rapid exponential expansion caused by a mysterious field. But what if inflation was just the outward eruption of a white hole? What if the universe didn't need a cause for expansion because it was the expansion of a previous collapse? This ties into the information paradox, too. When things fall into a black hole, where does the information go? Quantum mechanics says information can't be destroyed. But general relativity says it's trapped behind the event horizon, never to be seen again. Hawking radiation seems to leak energy, but not information. This has been a huge puzzle in physics for decades. But white holes might solve it. If every black hole eventually becomes a white hole, then all the information that fell in isn't lost, it's just delayed. It comes back out, eventually, through the white hole's eruption. That would make the universe fundamentally cyclical. Nothing would be truly destroyed, just transformed, hidden, and later revealed. Now let's dive into what happens to time near a white hole. Around black holes, time slows down. The deeper you go into its gravity well, the slower time moves relative to the outside world. But with white holes, the reverse could happen. Time could accelerate. For an object trying to escape a white hole's gravitational push, the closer it gets to the event horizon, the faster time might move from its perspective. That's hard to imagine, but it could mean that white holes not only mess with space and matter, but also with the flow of time itself. This opens doors to wild possibilities: time travel, causality violations, or loops in spacetime. And though most of these effects might be confined to microscopic white holes, the implications stretch far beyond. You might be wondering, why haven't we seen white holes if they're real? One reason is that they might be incredibly rare or short-lived. If they appear and disappear in seconds or less, we might not even register them as unique events. Another reason is that we may not be looking in the right way. Our telescopes are designed to detect continuous emissions, stars, galaxies, nebulae. White holes could be sudden, chaotic flashes, unlike anything else. It's like looking for fireflies with a camera that only takes one photo every minute. You miss the spark. But as our instruments get better, faster, more sensitive, more accurate, we may finally start catching those cosmic sparks. There's even a fringe idea that some white holes might be responsible for dark matter. If matter from other universes or other regions of space is being spewed into our universe through white holes, it might not interact with light or regular matter in the way we expect. It could pass right through us, detectable only by gravity. That's exactly how dark matter behaves, unseen, but with measurable gravitational effects. It's a stretch, but not impossible. The universe is under no obligation to be simple. In fact, the more we learn, the more it seems to revel in complexity. White holes force us to ask bigger questions too. What is space, really? What is time? Are they just tools we use to describe events, or are they actual things that can be twisted, reversed, reborn? Are we living in a universe that had a definite beginning, or are we caught in an eternal cycle of collapse and rebirth? These aren't just philosophical questions. They have mathematical weight behind them. And white holes sit right at the heart of that mystery. But its existence is theoretically possible and even hinted at in certain quantum field theories. If we ever find it, or figure out how to produce it, we might have the missing ingredient for stabilizing wormholes, and therefore, creating real pathways between black holes and white holes. Now imagine the implications of that. We could be looking at a cosmic transportation network, hidden in plain sight, only usable by civilizations far more advanced than us. Maybe the reason we haven't found intelligent alien life is because they're not traveling through normal space. They're using white holes and wormholes to leap across galaxies or even hop into entirely different universes. But there's more. Some researchers have proposed that white holes could be linked to quantum entanglement. You've probably heard of the term. Spooky action at a distance, where particles can instantly affect one another no matter how far apart they are. What if entanglement is not just a mysterious phenomenon, but actually a byproduct of deeper geometric structures, maybe even tiny, microscopic wormholes? Some physicists suggest that entangled particles are connected by minuscule Einstein-Rosen bridges, and that black holes themselves might be entangled with white holes through similar mechanisms. This could explain why information isn't lost in a black hole. It's simply being stored or processed somewhere else, connected through this invisible quantum bridge. That connection might be fleeting, but it would be real. And if we could find a way to detect or manipulate it, we could unlock a whole new level of physics, one where space and time are just tools, not limits. Then we get to time. If black holes slow down time due to intense gravity, white holes, hypothetically, might do the opposite. They could exist in a state where time flows differently, or even in reverse from our perspective. This doesn't mean someone could travel back in time by entering a white hole, but it raises fascinating possibilities about time's symmetry and how the universe evolves. Some theories suggest the arrow of time, why we remember the past but not the future, is actually linked to entropy, or disorder. A white hole, in reversing the process of a black hole, could be like a region where entropy decreases instead of increases. It would be like watching a shattered glass reassemble itself, or a star forming from scattered dust rather than exploding into it. If regions like that exist, it would challenge the very foundation of how we understand cause and effect. Now, let's touch on another fascinating idea, that white holes might not be explosions at all, but instead long, slow leaks. Rather than a sudden burst of energy, they might be objects that slowly emit matter over time. Think of them like ultra-dense geysers, steadily pushing out particles that had once been trapped in a black hole. This gradual release could match up with Hawking radiation, the slow evaporation of black holes. What if that radiation isn't just random energy, but actually the mechanism through which information and matter are being transferred into a white hole elsewhere? The leak could be so slow that it takes billions of years for a single atom to make the journey, but it would eventually arrive. Over immense timescales, this could result in the white hole building up enough mass to become visible, maybe even becoming a star-like object made of pure radiation. This brings us to the observational angle. Scientists have identified several high-energy phenomena in the universe that don't fit our usual explanations. One of the biggest mysteries is fast radio bursts, brief but incredibly powerful signals that come from deep space. These bursts last only milliseconds, but in that blink, they release more energy than our sun does in days. Some of them repeat. Some don't. And we have no idea what causes them. Could they be white holes? It's not out of the question. Their sudden appearance and massive energy output line up with what we might expect from a white hole event. Maybe what we're seeing isn't the birth of a new star or the collision of neutron stars, but instead the brief, final gasp of a white hole finishing its emission cycle. And we can't ignore the idea that white holes might be related to dark matter. You've heard of dark matter. It's the invisible stuff that makes up most of the mass in the universe. We can't see it, but we can see its effects on galaxies and gravity. Some theorists suggest that white holes, especially microscopic or stable ones, could be part of the dark matter population. They wouldn't emit light. They'd repel regular matter. And they could be everywhere, sitting silently in space, too small to notice, but numerous enough to account for the missing mass in our equations. If that's true, then finding a white hole might also solve the dark matter problem. One mystery would help crack another. And here's something to think about. What if white holes aren't cosmic rarities, but essential components of how the universe cycles matter and energy? Maybe the universe isn't a one-way street, but a massive recycling machine. Stars die, collapse into black holes, and eventually that matter comes back out through white holes somewhere else, reforming into new clouds of gas, new galaxies, and new stars. Over and over, like breathing. Inhale, exhale. Collapse, explode. The universe as a living, breathing thing, constantly renewing itself. We understand causality, memory, and the fundamental direction of the universe. It would imply that in some remote part of the cosmos, or some alternate version of it, events are playing out in reverse. The consequences of that idea are staggering. Could there be a mirror universe, birthed at the same moment as ours in the Big Bang, but where time flows backward relative to us? And could white holes be the link between the two, a kind of quantum bridge where our forward-moving universe touches its reverse-flowing counterpart? That idea is not just theoretical poetry. It's rooted in actual models being explored by physicists who think the universe may have a CPT, charge, parity, and time, symmetric twin, where every particle here has an opposite over there, and time itself plays in reverse like a movie being rewound. Now imagine if we ever located a white hole candidate, not just theorized it, not just modeled it on a supercomputer, but actually observed something in the sky that fit the predictions. What would that moment mean for humanity? The discovery of black holes was already earth-shaking. But a white hole would tell us that the cosmos isn't just about consuming and destroying. It would show us that there's a process of cosmic recycling happening on a level we've never fully appreciated. Matter that falls into a black hole might not be lost forever. It might emerge again, transformed, somewhere else, someone else. It would also give new meaning to the idea of information persistence in the universe. Physicists like Stephen Hawking wrestled with the idea of information loss in black holes. The current consensus is that information isn't lost but scrambled beyond recognition. White holes would offer a different answer. Maybe the information isn't just preserved, maybe it's released, restructured, and reintroduced into the universe like seeds scattered from a supernova. And what about the candidates we might already have? One possible white hole candidate is a mysterious object observed in 2006 called GRB 060614. It was a gamma-ray burst, a powerful explosion in deep space. But it didn't behave like a normal one. It lasted too long to be a typical short gamma-ray burst, and too short to be a long one. It didn't come from a supernova, as many long GRBs do. It didn't fit any of the known categories. Some theorists propose that it might have come from the sudden appearance of a white hole, blasting radiation into space in a single, short-lived event. Of course, this is speculative, but it shows how little we understand about certain high-energy phenomena. The truth is, we might already be seeing white holes without realizing it. Another potential clue comes from fast radio bursts, or FRBs. These are ultra-short, ultra-powerful pulses of radio waves that flash for milliseconds and then disappear. Some repeat. Some don't. They seem to come from galaxies billions of light-years away. And we still don't know what causes them. Magnetars? Collisions of neutron stars? Sure, those are possibilities. But what if some FRBs are the echoes of white holes blinking into existence for a split second, releasing trapped energy or information, and then collapsing again? If even one FRB turned out to be a white hole event, it would force a complete rewrite of astrophysics. And it doesn't stop there. There's a growing idea among quantum gravity researchers that our entire universe might be the interior of a white hole. That's right. Some models propose that what we call the Big Bang wasn't the beginning of everything, but just the bounce of a collapsing structure from another universe. In that view, the Big Bang wasn't a singularity at all, but the emergence of space and time from the other end of a black hole that existed in a previous cosmos. That cosmos collapsed into a black hole, which then rebounded and birthed our own universe through a white hole. So, we wouldn't be observing white holes from a distance, we'd be living inside one. Our whole universe could be expanding because we're inside the explosive output of an ancient gravitational rebound. If this is true, it means we are children of cosmic death and rebirth, born from the ashes of a dying universe. This theory, called the Big Bounce, resolves many problems with the traditional Big Bang theory. It avoids the need for a singularity, it incorporates quantum effects, and it suggests that the universe has no true beginning or end. Instead, it cycles. Expands, contracts, bounces, repeats. White holes are the crucial part of that cycle. They are not just mathematical artifacts or thought experiments. They are the heartbeat of the cosmos, pumping new energy and structure into reality after every collapse. And if we could confirm their existence, we wouldn't just be learning about strange cosmic objects, we'd be discovering a new cosmology, a new origin story for everything we see around us. But maybe the strangest idea of all is this: what if black holes and white holes are not two separate objects, but two perspectives of the same object, viewed from different dimensions? In some multidimensional models, like those inspired by string theory, a black hole might look like one thing from within our 3D universe, and completely different from another dimensional frame. To us, it's a region of space where nothing escapes. But to a being in a higher dimension, it might appear as something expanding, energetic, even creative. A white hole. That flips everything we think we know about reality. It suggests that what we call destruction may actually be creation viewed from the wrong side. That what dies here may be born elsewhere. That every end we fear might simply be a doorway, waiting for us to understand how to open it. We've trained our instruments to catch black holes by their gravitational effects and accretion disks, but white holes might leave a completely different signature. We might be calling them something else, like odd gamma-ray bursts, or unexplained fast radio bursts, or even misclassified quasars. What if some of the most mysterious phenomena we've catalogued in deep space aren't different things at all, but glimpses of white holes doing what they do, briefly rejecting matter and energy into the universe before fading away? And this opens up another problem. If white holes exist, how many are there? Are they rare, like cosmic glitches that barely ever happen? Or are they common, but hidden in plain sight? Think about the fact that most of the universe is dark matter, dark energy, and dark corners we haven't yet explored. It's very possible that white holes, if real, aren't just isolated phenomena. They could be integral to the very framework of the cosmos. Maybe every black hole has a corresponding white hole, but it exists so far away or in such a different state of spacetime that we can't correlate the two. Or maybe they exist inside the black hole itself, hidden behind the event horizon in such a way that whatever enters one side is ejected out the other, not in this universe, but in another. The implications of this are massive. It would mean the universe is not closed off, but porous. A black hole might not be a cosmic dead end, but a valve, part of a complex, interdimensional plumbing system that lets matter, energy, and maybe even information flow across boundaries we don't even know exist yet. Now let's get into the math for a moment, not with numbers, but with what it suggests. Einstein's equations allow white holes just as they allow black holes. In fact, the same math that describes a black hole, reversed in time, describes a white hole. This means white holes aren't just speculative sci-fi ideas. They're literally encoded into the language of general relativity. The problem is that the equations describe something that's possible, but not necessarily realized. And that's where quantum gravity comes in. Most physicists believe that at some point, especially near singularities like those found in black holes, general relativity breaks down, and quantum mechanics takes over. But we don't yet have a unified theory of quantum gravity. If we did, we might finally be able to describe exactly what happens inside a black hole, and what the mirror image, a white hole, really looks like. Loop quantum gravity, one of the most promising approaches to uniting these theories, suggests that black holes don't crush everything to an infinitely small point. Instead, they reach a point of maximum density, and then, get this, they bounce. That bounce is what could form a white hole. In this model, black holes don't just swallow matter forever. They eventually push it back out, through a white hole, possibly eons later. And now think about time again. We usually think of time as linear. You're born, you live, you die, cause and effect, beginning to end. But in the universe of black holes and white holes, time gets weird. You've probably heard about time dilation, how time slows down near massive gravity wells. Near a black hole, time can slow to a crawl compared to an observer farther away. But what happens near a white hole? If the physics are reversed, then maybe time speeds up, or behaves in a way that we can't even perceive. Imagine an object entering a black hole and re-emerging from a white hole, but what felt like seconds on one side could be millions of years on the other. That kind of time distortion could mean that information or matter entering a black hole in the early universe might only now be emerging from a white hole somewhere else. We might be seeing echoes of a distant past not by looking into deep space, but by watching white holes spitting out ancient material that was once lost to the darkness. And if we go a step further, what about consciousness? There are wild theories out there that speculate about the connection between consciousness and the fabric of the universe. Some even propose that information, like thought or awareness, might be a fundamental property of reality, like gravity or mass. If that's true, and if information can pass through black holes and come out white holes, then we have to ask a very unsettling question. Could consciousness itself pass through? Could something aware survive the journey? Could civilizations, coded into data or embedded into exotic matter, use white holes as a way to escape doom, travel far beyond their galaxies, or even cross into parallel realities? It sounds insane, but then again, everything about quantum physics used to sound insane. And now it's the foundation of all our technology. Here's another curveball. Some cosmologists think the universe itself may have started from a white hole. Think about the Big Bang, not as an explosion from nothing, but as a white hole event, expelling all the matter and energy we now see. It fits. The Big Bang had no observable cause. It was sudden. It involved a huge release of matter and radiation. And it created space and time as we know them. That sounds an awful lot like what a white hole would do. In fact, some have named this concept the Big Bounce, the idea that a previous universe collapsed into a black hole, and that collapse eventually rebounded into a white hole, which became our Big Bang. If true, then our universe is just one chapter in a cycle of universes, each one born from the ashes of the one before. It's a cosmic Ouroboros, a snake eating its tail, endlessly creating and destroying itself. And think about what this would mean for the nature of reality. If every black hole leads to a white hole, and every white hole could birth a new universe, then black holes aren't just objects, they're seeds. They're like cosmic embryos, containing all the ingredients for new space-time. That means inside the black holes we see scattered across the sky, there might be entire universes being born, evolving, and possibly even hosting their own stars, galaxies, and life. In this view, our universe could be just one of an infinite number, all branching off from others through black holes and white holes. That's the multiverse, not as a theoretical abstraction, but as a direct consequence of how matter and space behave at extreme densities. And if that's true, then we are not alone. Not just in terms of alien life, but in terms of entire realities, some possibly very similar to ours, others radically different, operating with entirely different laws of physics, where time, space, and matter behave in ways we can't even imagine. But the most haunting idea? We may never fully know. Because white holes, if they exist, might be inherently unreachable. Their repulsive nature means we could never get close. Their emissions might be too brief or too distant to study in detail. They could be gone before we even realize what they are. Or they could be hiding right under our noses, disguised as other cosmic phenomena, teasing us with partial truths. Maybe our current physics is just scratching the surface. Maybe we need a whole new paradigm, a new way to look at the universe, to even begin to understand what white holes really are. But one thing's certain, the idea of white holes forces us to ask deeper, more unsettling questions about the cosmos, and about ourselves. The catch is that while black holes are stable and seem to form naturally through known processes, like the death of massive stars, white holes appear to be unstable. Theoretically, even the smallest disturbance, like a single atom hitting a white hole's event horizon, would destabilize it and cause it to collapse or transform into a black hole. That makes them incredibly difficult to imagine as long-lasting objects in our universe. But maybe that's the point. Maybe white holes aren't meant to last. Maybe they exist only for the briefest moments, like cosmic hiccups, bursts of creation that come into being, release their payload, and vanish before anything can touch them. If that's the case, then looking for permanent white hole structures would be like trying to study lightning by catching it in a jar. You're looking for something explosive and fleeting, not static and stable. And here's where quantum gravity might change the game. See, the reason we struggle to understand what happens inside a black hole, or at the moment of a white hole's appearance, is because our current physics breaks down at extreme scales. General relativity works beautifully for large-scale structures like stars and galaxies. Quantum mechanics works perfectly for the tiny world of atoms and particles. But in a black hole, or a white hole, you need both at the same time. That's where loop quantum gravity comes in. It's one of the leading theories trying to unify general relativity with quantum mechanics. In this model, space and time aren't continuous. They're made up of tiny, discrete loops, like a woven fabric. According to this theory, black holes don't collapse into singularities. Instead, they reach a minimum volume and bounce, rebounding outward in the form of a white hole. Think of it like compressing a spring. There's only so far it can go before it pushes back. That bounce could be what turns a black hole into a white hole, at least in theory. What makes that idea so wild is how it reframes everything. If true, it means black holes don't just swallow things forever. They store that matter and energy until some future moment, when the spring releases and everything comes back out. That white hole phase could take billions of years to arrive, or it could happen on a different timeline altogether, one that we can't observe because it's separated from us by an event horizon or another dimension. In fact, some versions of this theory suggest that the Big Bang itself was a white hole, the rebound of a black hole that existed in a previous universe. That would mean we're living inside the explosion of another cosmos, like smoke pouring out of a blown fuse. This isn't just poetic speculation, it's a mathematically supported possibility. It takes the idea of the multiverse, the concept of infinite or cyclic universes, and ties it directly to the physics of black holes and white holes. It suggests that every end could be a beginning, every collapse a rebirth. And this leads to an even stranger thought. If white holes are real and connected to black holes, could we use them? Could they become wormholes? Tunnels through space-time that let us travel vast distances instantly? Some scientists have proposed that a black hole and a white hole connected by a tunnel could form a traversable wormhole. Of course, the conditions would have to be insanely precise. The tunnel would have to stay open, which means you'd need negative energy, a substance we've never confirmed exists, but which could theoretically keep a wormhole stable. Still, if even a sliver of that possibility turns out to be true, then the universe might be more like a network of tunnels than a scattered collection of isolated points. We could be looking at a map where every black hole is a possible door, and every white hole is a possible exit. That changes space travel from a fantasy into an engineering problem. It shifts the question from, is it possible? To, how do we survive the trip? But even if we never travel through one, just detecting a white hole would shake physics to its core. It would confirm time reversal symmetry in a whole new way. It would show that the arrow of time, the reason we remember the past but not the future, is not a fundamental law, but an emergent property. In other words, time might not really flow in one direction. It might just look that way because of how entropy behaves in our universe. A white hole would be living proof that the rules can bend, that under the right conditions, matter and energy can behave like a mirror image of everything we've ever known. It would also challenge the idea of causality, the principle that effects come after causes. In a white hole's frame of reference, that rule might be completely flipped. We'd be forced to rethink what it means for something to happen, before or after something else. There's also the psychological impact. If white holes exist, they show us that the universe has symmetry not just in space, but in time. And symmetry implies intention, not necessarily in a conscious sense, but in a structural one. It means the universe isn't random. It's balanced. It has rules that echo forward and backward. It has a logic that might extend beyond our perception. That's comforting in a way. It suggests that even the most chaotic explosions, the most violent deaths of stars, might have counterparts, events of release, renewal, and return. White holes would be the ultimate cosmic reminder that nothing is truly lost. That for every inescapable darkness, there might be a moment of blinding light, releasing everything that was once thought gone forever. And if we found one, if a telescope captured a burst of particles coming out of nowhere, with no cause we could trace, no collapsing star, no visible origin, we'd know we were looking at something historic. We'd be witnessing the reverse heartbeat of the universe. And once that happens, we won't be able to go back. Our understanding of everything, space, time, existence, would be changed forever. We'd be forced to rewrite our textbooks, our models, and maybe even our philosophies. And the most thrilling part? That moment could come at any time. A new telescope goes online. A new signal gets decoded. A strange flash is detected. And suddenly, we're no longer asking if white holes exist. We're asking what they mean. The more we dive into the possibility of white holes, the more it begins to feel like the universe is hiding something incredibly profound just behind the veil of what we think we understand. White holes could be keys, not just to the future of astrophysics, but to a completely different way of thinking about time, space, and the flow of information across the cosmos. See, one of the biggest mysteries in theoretical physics is whether information that falls into a black hole is truly lost forever. That goes directly against the principles of quantum mechanics, which say that information cannot be destroyed. If white holes exist and serve as an exit point for black holes, they might solve that problem. Instead of information being erased, it could just be stored, compressed beyond recognition, and eventually return to the universe in an entirely different form. That possibility has enormous implications, because it would suggest that every black hole might one day become a source of cosmic memory being released. The data, the particles, even the light that fell into it might be reborn into the universe through a white hole, scattered across time and space like a message from the past. Now think about what that means on a philosophical level. If white holes are real, then death itself, as represented by a black hole, might not be an absolute end. It might be a stage in a longer process, a phase of transition. Matter goes in, the laws of physics compress it to an extreme, but eventually it comes back out. That has echoes of rebirth, of cycles, of something ancient and cosmic repeating itself over and over in different forms. Black holes wouldn't just be the graves of stars, they'd be the wombs of something new. And that ties directly into another wild theory in cosmology, the idea that our universe itself may have been born from a white hole. That's not just poetic. It's something some researchers seriously explore, especially in models where the Big Bang isn't a beginning from nothing, but a bounce from a prior collapsed universe. In such a scenario, the Big Bang was actually a white hole event, blasting outward from the remains of a previous cosmic structure, possibly a black hole in a parent universe. It's a staggering idea, that universes can give birth to other universes through black holes, and that white holes are the channels through which that cosmic birthing happens. That also ties into what's called the Big Bounce model. Instead of a singular Big Bang, where time and space begin from a single point, the Big Bounce suggests that the universe contracts and expands in endless cycles. When it contracts to a certain critical density, it doesn't collapse into an irrecoverable singularity. It bounces back, expanding again. That bounce is mathematically very similar to what happens in certain white hole models. So, in a sense, our entire universe could be the inside of a white hole that formed after a previous universe collapsed. We might be living inside an ancient white hole without even knowing it. The galaxies, the dark matter, the cosmic microwave background radiation, it could all be part of the residue from the previous cycle, restructured and redistributed through the bounce. This concept isn't just imaginative, it fits certain equations that arise and loop quantum gravity and other quantum cosmology models. If those models are true, then white holes aren't just exotic objects floating out there. They are cosmic milestones, playing a role in the birth, death, and rebirth of everything. Of course, all of this leads to a huge question. If white holes exist, where are they? Why haven't we clearly observed one? The answer is partly in the nature of white holes themselves. If they exist, they'd likely be extremely short-lived. They'd emit all their energy rapidly, violently, and then vanish. That means if we weren't looking directly at the right part of the sky at exactly the right time, we'd miss it. But there's another possibility, that we've already seen white holes, we just didn't know what we were looking at. Some researchers think that mysterious phenomena like gamma-ray bursts or fast radio bursts, FRBs, might actually be white holes in action. These events come from nowhere, release massive energy in a blink, and then disappear. They don't seem to have any obvious physical structure behind them, like a star or a galaxy. Could it be that we're witnessing the final exhalations of ancient black holes, now transformed into white holes and dumping their contents into our universe? Gamma-ray bursts are especially interesting in this context. They're the brightest explosions we've ever observed in the universe, outshining entire galaxies for brief moments. Some are caused by massive stars collapsing into black holes, but others don't seem to have a clear origin. If some of these unexplained gamma-ray bursts are actually white holes opening for a split second and dumping eons of stored energy, that would completely reframe how we understand the high-energy universe. It would also mean that black holes have a built-in expiration timer, and that somewhere, deep in the far reaches of space or even near the edges of known galaxies, white holes are constantly being born and dying in the blink of an eye, little flashes of cosmic information being returned after an age in darkness. And then we have fast radio bursts, those puzzling, millisecond-long radio signals from deep space. They're so short and powerful that they baffle astronomers. Most of them seem to come from far beyond our galaxy, and some of them even repeat. But the mechanism behind them remains unknown. Could white holes explain this? Some theories suggest they might. A white hole, emerging from a black hole that had been dormant for billions of years, might expel its contents in a high-speed burst of radio waves as it collapses. That would match the suddenness and intensity of FRBs, and it would add yet another mystery to their origin. We still don't know for sure, but the possibility that these are echoes of ancient black holes coming back to life is enough to make anyone rethink what the universe is truly hiding. The irony of all this is that while white holes are incredibly difficult to observe directly, they might be all around us, in the data, in the background noise, in the unexplained phenomena we've cataloged but not yet understood. Every flash of unexplained energy, every burst of radiation with no clear origin, could be a white hole speaking in its own strange language. Maybe they are ancient, flickering signatures from before our own galaxy even existed. Or maybe they're part of a much larger process happening right now, cosmic recycling on a scale we can't yet comprehend. Whatever the truth, the search for white holes isn't just about verifying an exotic theory. It's about finding the missing half of a story we've only ever heard the first part of, the swallowing, but never the release. If we ever detect a white hole with certainty, it would be one of the most groundbreaking moments in the history of science. It would prove that black holes have a twin process. It would suggest that the universe has a kind of symmetry, a way of balancing creation and destruction. But more than that, it would mean that we live in a universe that stores memories, that holds onto the past, and eventually gives it back in unexpected ways. And the implications of that stretch far beyond physics. They touch on the nature of time, on the meaning of permanence, on the future of the cosmos. They might even hint at an answer to that old, enormous question: where does everything go when it disappears? As scientists keep scanning the skies and refining the mathematics, the possibility of discovering real white holes becomes more than just a dream. With each new burst of unexplained energy, with every radio wave from the edge of the cosmos, we get closer to uncovering a truth that might change everything we thought we knew about space, time, and the universe itself. Because white holes aren't just about matter and energy, they're about revelation. They're about the universe showing us that nothing is ever truly lost, only waiting to be seen again. If a universe-scale black hole really can give rise to a white hole that sparks another universe, then each cosmos becomes a stepping stone for the next. It's a chain reaction that could go back infinitely, with each universe birthing the next through gravitational collapse and explosive expansion. And that means our universe could be the child of an ancient, long-forgotten one, and we could be part of an endless cosmic family tree. The implications are wild. It reframes everything about time, causality, and existence itself. If that's true, the singularity inside a black hole isn't the end of the line. It's a chrysalis. It's where matter and energy undergo their most extreme transformation, and out the other side, something entirely new may emerge. White holes become the bridges between cosmic generations, and the universe becomes a living, evolving entity instead of a one-off explosion from nothingness. And here's another mind-bending twist. If white holes do eject matter and information that once fell into black holes, that opens up the possibility that we might already be seeing the remnants of white hole activity. We just don't realize it. There are mysterious, high-energy events we observe in the cosmos that still puzzle scientists. Gamma-ray bursts, fast radio bursts, or even unidentified cosmic rays might not be from traditional astrophysical sources. What if some of these strange signals are actually the aftershocks of ancient white hole eruptions? It's speculative, but it would explain the intensity, the suddenness, and the apparent randomness of these phenomena. In other words, space might already be whispering about white holes. We just haven't learned how to listen properly yet. Cosmic rays, for instance, sometimes arrive with energies so high that we can't easily trace their origin. They seem to come from nowhere, and their intensity defies explanation from normal astrophysical processes. If these particles were ejected by white holes, especially from ancient black holes that existed long before galaxies even formed, that could account for their mysterious nature. These rays would have traveled across time and space, perhaps even from another universe entirely. That's not science fiction. That's physics testing its own boundaries, searching for answers in the data that don't fit our current models. White holes could be the missing piece that connects unexplained observations to a new layer of understanding. And speaking of unexplained observations, there's also the question of entropy, the measure of disorder in a system. Black holes famously challenge our understanding of entropy because they seem to swallow information without increasing the universe's overall disorder. But if white holes return that information, then the books are balanced. That means white holes might be essential in preserving the second law of thermodynamics across cosmic timescales. They'd be the universe's way of keeping track, ensuring nothing is truly lost, only hidden and returned later in a different form. And if that's true, it gives white holes a much deeper role than just being the opposite of black holes. They'd be fundamental to how the universe maintains its rules over billions and trillions of years. Now, let's talk about time. Black holes warp time to such extremes that, from the outside, anything falling in seems to slow down infinitely. But white holes flip that dynamic. Theoretically, time flows out of them, pushing everything away instead of pulling it in. That's why nothing can enter a white hole, not even light, because its internal clock is always pushing forward, always expelling, always denying entrance. It's as if time is reversed inside a white hole. And if time is reversed, then causality, the basic order of cause and effect, might also operate differently inside. That's a territory no physicist fully understands yet. But it opens up questions like, could white holes exist in a backward-moving universe? Could we be inside one and not know it? If a white hole exists and is large enough, it could mimic some properties of the early universe. It would have an extremely high temperature, it would be expanding rapidly, and it would contain vast amounts of energy being ejected at once. Sound familiar? That description fits our own Big Bang very closely. That's why some physicists believe that the Big Bang might not be a singular explosion from nothing, but rather the visible result of a white hole explosion from another cosmic event. And if that's true, it also means that our entire observable universe could be the inside of a white hole. That flips the whole structure of space upside down. What we thought was expansion might actually be a massive ejection event in progress, and our universe could still be inside that white hole's boundary. There are mathematical models that support this. In loop quantum gravity, a theory that attempts to unify general relativity with quantum mechanics, black holes don't collapse into singularities, but instead reach a maximum density and bounce. This bounce forms the basis for a white hole. And if this model is accurate, then black holes are not infinite pits, but tunnels, bridges between phases of the universe or even between universes. They are the transition points where gravity stops crushing and starts repelling. That could mean that every black hole eventually becomes a white hole given enough time, and the process may be slow, taking billions or even trillions of years. But it also might be the natural life cycle of extreme gravity: compress, rebound, explode, repeat. Now, what about detection? If white holes exist, how would we find them? It's not easy because by definition, they repel matter and don't allow anything in, which means they wouldn't behave like stars or galaxies or even black holes, which emit X-rays through accretion disks. A white hole wouldn't have that. It wouldn't feed on matter. It would just exist, expelling radiation and matter in bursts, probably very suddenly. That means we'd have to catch them in the act of exploding, which could be rare or unpredictable. Or we'd need to study ancient regions of the cosmos where unexplained high-energy events occurred, looking for patterns or echoes that match theoretical predictions. It's like searching for a firecracker after it's already gone off and trying to reconstruct what caused the sound from the leftover smoke in the air. There have been a few white hole candidates proposed, though none are confirmed. One of the most intriguing was an unusual gamma-ray burst detected in 2006. It didn't match the profile of any known supernova or collapsing star, and it was too short to be a typical long-duration gamma-ray burst. Some researchers speculated it could have been a white hole event, a spontaneous burst of energy from nowhere. That doesn't mean it was. But it does show that astrophysical events still pop up that we can't fully explain, and white holes remain a possibility worth keeping in mind, especially as our instruments become more precise. Another idea is that mini white holes could exist, tiny versions formed during the early universe, perhaps at the quantum level. If so, they could be popping in and out of existence, ejecting tiny bursts of energy, and disappearing before we even notice. These quantum white holes might play a role in things like dark matter or unexplained cosmic noise. They're hard to detect, but they might be all around us, part of the fabric of space-time in ways we don't yet understand. It's like the universe has a background process running quietly, full of glitches, bursts, and strange phenomena that hint at deeper laws. And if white holes are real, they don't just connect past and future, they might connect different regions of space. They might be one half of a wormhole, with black holes being the entrance, and white holes being the exit. Wormholes are theoretical tunnels through space-time, and while we haven't confirmed their existence, they're consistent with Einstein's equations under certain conditions. If they do exist, they could provide shortcuts across the universe, or even into other universes. That means white holes wouldn't just be fountains of energy. They'd be destinations, outposts on the far side of cosmic travel. But again, the energy conditions to keep a wormhole stable are extreme, possibly impossible, which makes this an exciting but very speculative frontier. White holes, if they really do exist, might not just be a reverse black hole, they could be an entirely different kind of object that breaks everything we think we know about time, space, and causality. Unlike black holes, which trap everything that enters them, white holes theoretically expel matter and can't be entered from the outside. That's where things get especially strange. If nothing can go into a white hole and everything only comes out, how does it exist in the first place? How did it form? Some physicists think it might be the other side of a black hole. Others argue it could be a quantum phenomenon where space-time folds in on itself in extreme ways we can't fully comprehend yet. Either way, it challenges one of the most basic rules of the universe, the idea that cause comes before effect. With white holes, time might work backwards. What looks like an explosion today might actually be the result of something that hasn't happened yet, or something that happened in an entirely different timeline. There's also the question of stability. If a white hole were to exist in our universe, how long could it actually last? Some models suggest it would instantly collapse or turn into a black hole again because of the immense gravitational pressure around it. But other theories suggest that if a white hole formed as part of a cosmic bounce, where a collapsing universe gives birth to a new one, it could remain stable long enough to shape a new cosmos. That idea completely changes our understanding of death and rebirth on a universal scale. It suggests that destruction is never final, and every end is secretly a beginning. This cycle of collapse and expansion might be the true rhythm of the cosmos, a cosmic heartbeat pulsing across eternity. The idea of white holes also forces us to reconsider how we think about time. In our daily experience, time moves forward, second after second, day after day. But in a white hole, the normal rules of time may not apply. What if inside that boundary, time flows backward? What if an observer falling into a black hole could eventually emerge from a white hole in a different universe, experiencing time in reverse along the way? That would mean the arrow of time isn't a fixed direction but a local effect, dependent on gravitational conditions. It's mind-bending to think that two observers could experience time in completely different directions depending on where they are in space, and even more so to imagine that time could split, reverse, or loop around inside these exotic objects. Some scientists working on theories of loop quantum gravity, an attempt to unify general relativity and quantum mechanics, propose that the singularity at the center of a black hole might not be a true singularity at all. Instead of infinite density, the matter inside might reach a limit and then bounce back, triggering a kind of shockwave through spacetime that creates a white hole. This bounce could be the mechanism that prevents the complete breakdown of physics, offering a kind of escape route from the collapse. It's not just a theoretical fix, it might actually describe a real physical process that happens in extreme environments, far beyond anything we can recreate here on Earth. And if that's true, then white holes aren't just a curiosity, they're the key to understanding what happens at the deepest level of reality. Even more intriguing is the idea that some white hole candidates might already be visible in the universe. We just haven't recognized them for what they are. There are certain cosmic phenomena that don't quite fit into our current models. Fast radio bursts, for example, are sudden, ultra-powerful pulses of radio waves that come from distant galaxies and last just milliseconds. Their exact cause is still unknown, but some researchers have speculated that they might be signals from white hole eruptions, brief moments where energy trapped inside a collapsed star is suddenly expelled into space. Similarly, some unexplained gamma-ray bursts and even mysterious patterns in the cosmic microwave background might be the faint fingerprints of white holes echoing through time. There's also speculation about the role of white holes in the ultimate fate of the universe. If the cosmos is constantly expanding, cooling, and stretching toward a state of emptiness, what brings it back to life again? One idea is that at the end of everything, when galaxies have faded, stars have died, and black holes have evaporated, the last remaining energy collapses into ultramassive black holes. And from those, new white holes form, sparking the birth of entirely new universes. In this view, the death of one cosmos becomes the seed of the next. White holes become the bridge between one reality and the next, acting like portals through which new versions of time, space, and matter are born. Another fascinating idea is that white holes could be responsible for some of the oldest and most mysterious features of our own universe. There are regions of space that appear oddly smooth, uniform, and connected in ways that shouldn't be possible according to standard models of cosmic inflation. But if our universe began as the interior of a white hole, those initial conditions could be explained. Everything that came out of that white hole would be causally connected, even across vast distances, because it emerged from a single point of collapse in a prior universe. That could explain why the universe looks so strangely balanced, like it was fine-tuned from the very beginning. Because in a way, it was, by the structure of whatever came before. Physicists have even explored the possibility that white holes could provide a natural resolution to the information paradox, the problem that arises when quantum information seems to disappear inside a black hole, violating the laws of quantum mechanics. If information falls into a black hole and is eventually emitted by a white hole somewhere else, then nothing is lost, only transformed and relocated. That would mean the universe never truly forgets. Every particle, every bit of data, every event would be preserved in some way, even if it takes billions of years or a journey across universes to re-emerge. And if white holes are part of a larger multiverse structure, then maybe each one doesn't just expel energy and matter, but gives birth to new physical laws entirely. That could mean gravity works differently in another universe. Time might not be linear. Matter might not clump together into stars or galaxies. There might be universes with no atoms, no light, or no space as we know it, all depending on the conditions inside the white hole that spawned them. In that context, white holes aren't just rare or strange, they're fundamental engines of cosmic creativity, churning out infinite variations of existence. What's even wilder is the idea that if white holes exist, and if they create new universes, then perhaps every black hole we've ever seen is secretly a universe factory. Maybe inside each one lies the seed of a new reality. And maybe, from the outside, we just see them as dark spheres in space. But from the inside, a whole cosmos could be unfolding. That would mean we are part of an infinite recursive structure, where every universe gives birth to more, endlessly. It's a beautiful, humbling, and overwhelming possibility, one that forces us to admit how little we still understand about the true nature of the cosmos. Now, moving beyond what we think we know, let's talk about something that doesn't get enough attention: what white holes could mean for the flow of time. Time, to us, always seems like it's moving in one direction, forward. But white holes challenge this idea in an extremely strange way. See, While black holes are places where nothing can escape and time seems to stop as you fall in, white holes might be the opposite in terms of time too. Instead of being a place where everything is pulled in and time grinds to a halt, white holes could be where things are expelled violently and time might actually reverse, at least relative to what's happening outside. It's not that your clock runs backward, but that the arrow of time around a white hole might be flipped in some way we still don't understand. This breaks our sense of cause and effect. It suggests that in some parts of the universe, the future might lead to the past, and what we see as the start of something might really be the end, just playing in reverse. That alone is a mind-breaking concept that physicists are still struggling to fully model, because it doesn't fit cleanly into our equations. And if it turns out to be real, it means we've been misunderstanding the direction of time itself. Another weird possibility tied to white holes is that they might not even be isolated objects. They could be deeply connected to black holes in a hidden way. This is where something called a wormhole comes into play. If you imagine space as a two-dimensional sheet of paper, and you fold that paper so 2 points touch, you could poke a hole through and connect them. That's the basic idea behind a wormhole. Now imagine this: a black hole sits at one end, pulling things in. On the other end, in a completely different part of the universe, or maybe even another universe entirely, a white hole sits there spewing matter out. If that's the case, then maybe what gets sucked into a black hole doesn't vanish forever. Maybe it gets squeezed through this insane shortcut in space-time, and comes shooting out of a white hole somewhere else. This could even explain strange phenomena we've seen, like gamma-ray bursts or unusual energy signatures from deep space that we can't yet explain. Could some of those be the output of white holes connected to black holes on the other side of the universe? Of course, that opens up another mind-bending idea: what happens to information? One of the most infamous problems in physics is the information paradox, related to black holes. When something falls into a black hole, the theory says it should disappear completely. But quantum physics says information can't be destroyed. That's a huge contradiction. If white holes exist, they might be the missing half of the puzzle. Maybe they're where the information goes. Maybe, instead of being lost, everything that falls into a black hole is eventually spit out of a white hole, not just matter and energy, but the actual blueprint of what fell in. That would keep information safe in the universe and solve a huge theoretical crisis that has had scientists arguing for decades. It could also mean that white holes act like giant cosmic memory dumps, spewing out the detailed remains of ancient galaxies, stars, even civilizations, although we wouldn't recognize any of it. And speaking of civilizations, here's a thought that takes this whole thing into even crazier territory. What if advanced lifeforms already understand white holes? If a civilization had technology so advanced it made ours look like cave paintings, they might be able to manipulate black holes and white holes. They could potentially use white holes as energy sources, time machines, or even escape hatches from dying parts of the universe. If they understood how to travel through wormholes, linking black holes and white holes, they could move through space instantly or even hop between different universes. This isn't pure science fiction either. Some serious physicists have suggested that the energy coming from certain regions of space might not be natural, that it might be artificial signals, maybe even attempts to control or stabilize wormhole exits. And if white holes are involved, that would be the kind of structure they need: stable, exotic, and massively energetic. Now let's step into the even darker territory: the possibility that white holes are short-lived. Some scientists think that if white holes do exist, they might not last long. They could blink into existence, spew out a bunch of energy and matter, and then disappear just as fast. In this view, white holes are like cosmic hiccups, rare, brief explosions that maybe mark the end of black holes or the birth of new universes. These events might be so fast and so strange that we've already seen them and didn't recognize what they were. Think about fast radio bursts, those mysterious, powerful signals we get from space that last just milliseconds. We still don't know where they come from. Some believe they could be linked to white holes briefly punching through into our universe, shouting once, and then vanishing. And here's something even wilder: what if our universe itself came out of a white hole? Some physicists have proposed that the Big Bang, the moment when all of space and time exploded outward from a single point, might not have been a true beginning. Instead, it could have been the output of a white hole from another universe. That idea completely rewrites the story of where we came from. It means the birth of our universe wasn't the first event ever. It was just one link in a chain of connected realities. This makes white holes more than just rare objects. It makes them cosmic bridges, birthing entire universes on the other end of black hole collapses in other dimensions. And that means somewhere out there, in a completely separate universe, there might be creatures staring into a black hole in their night sky, unaware that what they're looking at is the thing that created our entire reality. When you consider all this, time reversal, wormholes, information paradoxes, universe-spawning explosions, and the possible fingerprints of alien intelligence, white holes stop being just a mathematical curiosity. They become one of the biggest mysteries out there. Not just because we haven't seen one, but because if they do exist, they force us to change everything we thought we understood about space, time, reality, and even life itself. They're like cosmic riddles, and every time we think we're getting close to solving them, they get weirder. But maybe that's the point. Maybe white holes are there not to give us answers, but to push us into asking better questions. Questions about where we're from, where we're going, and what this universe is really made of beneath the surface. That idea alone changes everything we thought we knew about reality. It suggests that black holes and white holes aren't just opposites in theory. They could be part of the same system. One consumes. One expels. What disappears in one region of space might reappear somewhere else, possibly light years or even entire dimensions away. Think about that. All the matter, energy, information, and maybe even time that collapses into a black hole might be preserved, not destroyed, and launched back out of a white hole. That would make white holes not just theoretical anomalies, but actual portals or escape valves in the universe's deepest systems. If true, this could solve one of the biggest mysteries in physics, the black hole information paradox. Because if information isn't lost in a black hole but instead ejected through a white hole, then maybe nothing ever disappears forever. Now, the real twist here is how that connects to quantum mechanics. Our universe is weird on a large scale, but it gets even stranger when you look really small. At the level of particles, things don't act like solid, predictable objects. They behave like clouds of possibility. And some physicists think white holes might only make sense when you combine general relativity with quantum theory. For example, some models suggest that white holes could be formed from the rebirth of evaporated black holes. As a black hole slowly loses mass due to Hawking radiation over billions of years, it might shrink to a point where quantum effects completely take over. Instead of collapsing into nothing, it might bounce. And when it bounces, it could explode back out as a white hole. That bounce wouldn't be like anything we've ever seen. It would be an extreme release of energy and space-time curvature, possibly spreading out the information that had been trapped inside for eons. One important idea that often gets overlooked is that white holes may not be entirely stable. Unlike black holes, which are held together by their incredible gravity, white holes are violent, outward-pushing monsters. Some models say they'd be unstable and collapse almost instantly after forming. That might explain why we've never seen one clearly. They either don't last long or are buried in data we don't yet recognize. It could be that the universe is littered with the corpses of ancient white holes that collapsed almost as fast as they were born. Or maybe they're hiding in plain sight, mistaken for supernovae, gamma-ray bursts, or other extreme cosmic events. Here's where things get even crazier. Some theorists believe white holes might not exist in our universe right now, but they could have existed just after the Big Bang. In the first few seconds of the universe, space and time were so hot and dense that the laws of physics were practically melting. In that chaos, white holes might have formed temporarily as space-time expanded and cooled. These primordial white holes could have played a role in shaping the early universe, kicking matter outward and helping structure the cosmic web we see today. If that's true, then white holes weren't just weird one-off phenomena. They were part of the original recipe for how everything came to be. Another idea, What if white holes aren't just cosmic plumbing systems or relics of the past? What if they're still out there, active, and we just don't know how to look for them? Maybe they don't shine like stars, and maybe they don't act like anything we can recognize right now. Their signals could be hidden behind radio static or buried in strange gravitational waves that we haven't properly decoded. It's even possible that one of the many fast radio bursts we've detected could be the signature of a white hole explosion from light years away. Those bursts happen suddenly, they're incredibly powerful, and we still don't have a solid explanation for most of them. Could they be the last breath of an ancient black hole finally bouncing back into the universe? Here's something even wilder. Some theories suggest that our entire universe might have been born from a white hole. Yeah, you read that right. Instead of a singularity that exploded into everything, like in the traditional Big Bang model, our universe might be the inside of a white hole. That would mean our universe is expanding not because of some undefined bang, but because it's still being ejected from some larger system, a white hole in a bigger parent universe. This ties into something called the Big Bounce theory. Instead of one beginning, the universe goes through cycles of collapse and explosion. A universe collapses into a black hole, compresses, then rebounds as a white hole, starting a new universe with slightly different properties. That could mean our universe is just one of many in an endless cycle. And if that's true, then every black hole we see might eventually become a white hole and give birth to an entirely new cosmos. That turns black holes into not just destructive forces, but cosmic seeds. And we haven't even talked about the edge cases yet. Like, what happens if you send information into a black hole that turns into a white hole? Would that information survive? Could you send a signal through a black hole and get it back out through a white hole? That's pure sci-fi territory, but some physicists are seriously trying to calculate whether a particle could make that trip. If it could, and if we could detect it, then that opens the door to faster-than-light messaging, or even travel. Of course, it's all deeply theoretical and would probably require energy levels we can't even begin to produce. But the math doesn't completely rule it out. And the universe tends to surprise us more often than not. Now let's dive deeper into the possible observational evidence. There are a few things astronomers have found that don't line up with what we'd expect from known physics. Some events in deep space, like unexplained gamma-ray flashes or strange cosmic jets, don't have clear causes. They're often brushed off as exotic black hole events, but that could just be our way of saying, we don't really know. If white holes are real, and especially if they're short-lived or hidden, then maybe these strange bursts are the only hints we get. Imagine trying to prove the existence of something that lasts only a few milliseconds and can only be detected by a brief, powerful pulse. It's like trying to understand a thunderstorm from a single lightning strike. There's just not enough data. But with the rise of new observatories and next-generation telescopes, we're starting to gather more pieces of the puzzle. Maybe we've already seen a white hole, we just didn't know it at the time. And here's another twist. Some scientists have floated the idea that dark matter might be connected to white holes. Dark matter is the stuff that holds galaxies together. It doesn't shine, doesn't absorb light, and we can't see it directly. But it has gravity, and it makes up most of the matter in the universe. If white holes are out there pumping matter or energy into space in very specific ways, maybe they're part of what creates or sustains dark matter fields. It's a stretch, but not impossible. White holes, by their very nature, would be invisible except for their effects. That's exactly how dark matter acts. It doesn't shine or reflect. It's just there. If the two are connected, then studying white holes could actually help solve another of the biggest mysteries in astrophysics. Now let's talk survival. If white holes are real, and if they can form suddenly, maybe even from collapsed black holes, then is it possible one could just appear? Like, could a white hole explode into existence near Earth? Thankfully, the answer seems to be no. The odds of one forming close to us are ridiculously low. And even if it did, the energies involved are likely to dissipate so quickly that it would be over before we even registered it. Still, it raises unsettling questions. If the universe has these high-energy outbursts waiting to happen, then we're basically passengers on a ride where new rules could kick in without warning. That's not to say we're in danger, but it does mean the cosmos might be a lot more dynamic than we thought. Exist in forms so alien to our current instruments and understanding that we've seen them already but labeled them as something else. Strange gamma ray bursts, unexplained flashes of radio waves, or mysterious patterns in cosmic background radiation. These cosmic oddities pop up from time to time, completely unexpected and unexplained, but they don't fit nicely into any category we already know. What if, hidden among those strange signals, are the fingerprints of white holes, brief, furious outbursts of matter and energy tearing through the fabric of space-time for just moments before disappearing forever? The truth is, we might be staring at these cosmic messages and missing the point entirely because we're still stuck thinking inside the framework of black holes and stars. White holes might not look like anything we expect. They could be chaotic, fast, and disguised by cosmic noise. We might need an entirely new kind of observation method, or a better understanding of space-time, before we even know how to spot one for sure. Another wild idea that builds off this is that white holes could be older than our universe, or even outside of it. According to some interpretations of the Big Bounce theory, the universe might not have started with a single Big Bang, but with the rebound of a prior collapsed universe. In that theory, a previous cosmos collapsed into an ultra-dense state, essentially a universal black hole, and then bounced into a new expansion. If that bounce happened, then what exploded outward could technically be described as a white hole. In that case, our entire universe might have emerged from one unimaginable white hole. That means the universe isn't a one-time event but part of a cycle: collapse, bounce, expansion, repeat. And each cycle could start from what we'd call a white hole, carrying information, energy, and structure from the previous one into the next. The implications are enormous. It means white holes might not just be objects within the universe, but the actual seeds of universes themselves. Let's not forget how this ties into the question of multiverses. If white holes are ejecting matter and energy not just across space, but between universes, then they could be bridges, cosmic tunnels that punch through the boundaries of our known reality. When you start looking at equations in loop quantum gravity or certain versions of string theory, this idea doesn't seem so far-fetched. A white hole could be the exit wound of a black hole in another universe. That turns our whole idea of space into a kind of interdimensional sponge, where matter and energy leak in and out of universes through black and white holes like cosmic plumbing. It's a terrifyingly big idea. It means that what we see is just a tiny slice of a much larger structure, a structure where white holes are not rare but essential, keeping the multiverse interconnected and flowing. There's also something poetic about white holes in this context. Black holes have always been seen as the destroyers, the ultimate ends. But white holes flip that story. They suggest that the end of something might not be an end at all. Maybe death, collapse, and compression aren't the final step. Maybe they're a transition. A pause. And then, boom, rebirth through a white hole. Think about what that says not just about physics, but about the universe's mindset, if you want to put it that way. It's not about endings. It's about transformation. White holes could be the universe's way of recycling the dead and forgotten, giving them one final, spectacular exit into a new world. But for now, all we can do is chase the clues. Physicists are looking for patterns in cosmic rays, gravitational waves, fast radio bursts, anything that might hint at something being ejected violently out of nowhere. Some researchers are even going back through decades of data to see if we missed something obvious. One day, we might find a flash in the sky that can't be explained any other way. And when we do, it might not just be the discovery of a white hole. It could be the discovery of an escape hatch from everything we thought we knew about space, time, life, and death. Imagine that every time a black hole forms, instead of leading to a dead end, it opens a doorway somewhere else, one that explodes outward in a different cosmic space. That outward explosion could be the birth of a white hole. Now stretch that further. If there are countless black holes throughout our universe, there might be countless white holes scattered across an infinite multiverse. They might not just be scattered randomly either, they could be systematically connected, like an unseen network of tunnels. Each tunnel might carry matter, energy, and even the underlying code of reality itself from one universe to another. If true, white holes aren't just rare theoretical ideas. They're fundamental to how everything is connected across the entire structure of existence. And if white holes can connect universes, it might explain why our universe seems so finely tuned for life. Maybe it isn't a coincidence. Maybe what gets transferred from one universe to the next isn't just mass and energy, but also rules, physical constants, forces, and dimensions. In this view, universes with stable laws and rich structures are more likely to spawn black holes, which then seed white holes, creating more universes like themselves. It's a kind of cosmic natural selection, and white holes are the delivery system. This is called cosmological natural selection, and it's an idea that might make white holes responsible for not just spreading matter, but evolution itself, on a universe scale. That means white holes wouldn't just be odd little cosmic quirks, they'd be central players in the grand machinery of existence. What's even crazier is that some physicists suggest white holes might already be right under our noses, hiding in plain sight, not as distant bursts or rare phenomena, but as the very things we've been trying to explain for decades. There are these strange objects called fast radio bursts, or FRBs. They're intense, millisecond-long blasts of radio energy coming from deep space. We don't know what causes them. They're too powerful to be regular stars and too fast to be typical explosions. But some models suggest that FRBs could be caused by white holes blinking into existence, and then vanishing almost instantly. That's exactly the kind of short, high-energy signature a quantum white hole might produce, one that appears briefly, spews out energy, and collapses. And it doesn't stop there. In recent years, astronomers have observed ultra-high-energy cosmic rays, particles flying through the universe with energies far beyond what we can explain using known processes. Some of these rays don't seem to come from any galaxy or known source. They just appear, as if spat out randomly into the cosmos. White holes are once again on the list of suspects. If a white hole exploded in intergalactic space, far from stars, galaxies, or any normal structure, it could launch matter at incredible speeds, flinging particles across the universe with so much energy that they travel for billions of years before we detect them. And because we don't know where they came from, we're left guessing. White holes are one of the few explanations that actually make sense in some scenarios. But then there's the deeper problem. If white holes exist, why haven't we found undeniable proof of one? The answer might be that we don't know exactly what we're looking for. White holes could come in many sizes, shapes, and lifespans. Some might form instantly and disappear just as fast. Others could be leftovers from an earlier universe, hiding in the deepest parts of space-time, inaccessible with our current tools. It's possible that a white hole doesn't even look like anything we expect. It might not have an event horizon, like a black hole. It might not be round or symmetrical. It might be chaotic, fragmented, or spread across dimensions we can't even perceive. So, while we're pointing our telescopes at the sky and running computer models, white holes might be doing their thing in ways we simply don't have the language to describe yet. And here's another layer that could blow your mind. In 2018, a group of physicists proposed that the Big Bang itself, the moment our universe began, could have actually been a white hole explosion. According to this theory, everything we now see, from stars to galaxies to empty space, came from an imploding black hole in a parent universe. That black hole reached a quantum limit, rebounded, and exploded outward as a white hole, our universe. If that's true, then white holes aren't rare at all. They're how universes are born. It flips the script. Instead of being a freak event, a white hole might be the most important event in the history of reality. Think about what that implies. It means the reason we're here, why atoms exist, why space has structure, why time flows forward, could all be due to a single white hole moment that lit the spark of the universe we now live in. It wasn't some random bang out of nowhere. It was the release of compressed energy and information from a collapsed reality, bursting into expansion. And just as that process might have birthed us, the black holes forming in our universe today might be quietly preparing the seeds of the next one. It's a never-ending cycle, and white holes are the midpoint, the moment of reversal from collapse to expansion. Now, imagine how strange that makes time itself. In our daily experience, time moves one way, from past to future. But if white holes are time-reverse black holes, then maybe time flows differently inside or around them. A white hole might actually push things backward in time relative to an outside observer. That would be a huge problem for causality, the idea that cause comes before effect. But quantum theory already plays fast and loose with causality at small scales, so maybe, under extreme conditions, time itself becomes flexible. That means if we ever find a white hole, it could not only reveal secrets of space but also totally upend our understanding of time. And then there's the ultimate question: what would happen if a human, or a spaceship, tried to approach or enter a white hole? Theoretically, it wouldn't be possible. The closer you get to a white hole, the stronger the outward push. Unlike black holes, which pull everything in, a white hole would repel anything that comes close. It would be like trying to walk into a windstorm so strong that not even light could move forward. But what if, under the right conditions, some special trick of gravity or space-time, a wormhole opened up, allowing passage from a black hole to a white hole? That's one version of a traversable wormhole. It would be the ultimate cosmic shortcut, traveling from one end of the universe to another, or even from one universe to another. Some mathematical models support this idea. In fact, Einstein and Rosen, in their early work, proposed what we now call an Einstein-Rosen bridge, which connects a black hole to a white hole through a hidden throat in space-time. Later, this idea evolved into modern wormhole theory. The problem is, these structures seem to collapse before anything can go through them, unless there's something holding them open. That something would be exotic matter, a theoretical substance with negative energy. We haven't found it yet, but quantum fluctuations suggest it might exist. If we could create or harness exotic matter, we might be able to stabilize a wormhole, and use a white hole as the exit. And all of this brings us to a haunting thought: what if white holes exist but only activate under special, extreme conditions? Maybe they're dormant, like cosmic volcanoes, waiting for the right moment to erupt. A supermassive black hole might take billions of years to gather the right amount of mass and reach the quantum bounce threshold. Then, all at once, boom, a white hole forms, explodes, and vanishes. If we could predict when and where that happens, we might catch one in the act. But it's like watching a clock that runs once every trillion years. You need patience beyond anything humans have ever practiced. And here's the twist: if a white hole ever forms near us, it might be dangerous. All that expelled energy could disrupt planets, solar systems, even galaxies. We think of them as beautiful theories, but if one went off in our galactic neighborhood, it might tear apart the fabric of space around us. Or worse, it might overwrite reality in its path, bringing in physics, particles, or even time from another universe. That makes white holes not just fascinating, but possibly hazardous in ways we can't predict. Unlike black holes, which trap light and stretch time, white holes would erupt energy and matter in an instant, creating a flash so brief and intense that it could be mistaken for some kind of radio anomaly. But it wouldn't be noise. It would be a signal from the very edges of our physical understanding. If true, that would mean we've already seen white holes dozens or maybe even hundreds of times. We just didn't realize what we were looking at. And the idea that they're so brief, so sudden, fits perfectly with the theoretical nature of white holes, short-lived cosmic explosions that refuse to obey our normal rules of space and time. If we go deeper, there's also the possibility that white holes aren't just real. They could be the reason we even exist in the first place. Some researchers have suggested that the early universe itself, just moments after the Big Bang, behaved very much like a white hole. In that initial instant, everything exploded outward from a singularity, spreading matter and energy in all directions, with no apparent origin point within the existing universe. That kind of description matches the behavior of a white hole, energy and matter bursting outward from a boundary beyond which nothing can enter. So the beginning of everything, the origin of space, time, matter, and energy, might literally have been the result of a white hole-like event. If this is true, then white holes aren't just part of the universe's story, they are the first page. Even more interesting is how this ties into information theory. One of the big problems with black holes is the so-called information paradox. In theory, when something falls into a black hole, the information about it, the specific details of its structure and identity, is lost forever. But that breaks the laws of quantum mechanics, which say information can never truly be destroyed. Some theorists believe white holes could be the solution. Instead of destroying information, black holes might store it temporarily and eventually release it through white holes. That means white holes might be the universe's way of keeping balance. Every bit of information, every particle, every atom that goes and doesn't vanish, it gets spit back out in another place, at another time, maybe even in another universe. That would make white holes not just spectacular, but necessary. And now we come to an even stranger idea: white holes and consciousness. Some physicists and philosophers have speculated that the laws of the universe are tuned not just for matter and energy but for awareness itself. There's a theory known as panpsychism that suggests consciousness is a fundamental aspect of the universe, like mass or charge. If that's true, and if white holes really are as deeply embedded in the structure of spacetime as some believe, then maybe they're connected to the flow of information and awareness in some unimaginable way. If white holes transmit information across time and space, could they be part of a cosmic consciousness? It's wildly speculative, but some thinkers have pointed out that the brain and the universe both process information in surprisingly similar ways. White holes might be a kind of neural network at the scale of galaxies. Let's not forget the connection to time. Black holes stretch time so much that near their edges, time slows down to a crawl. But white holes, if they exist, would flip that effect completely. Near a white hole, time might speed up dramatically, or behave in a way that seems backward from our normal experience. This could mean white holes might be natural time machines, not for people, but for particles and information. If that's true, then white holes might let us see back into the distant past or send information forward into the future. We might never be able to enter or survive near one, but they could be critical in understanding how time really works on a fundamental level. They could hold the key to breaking the barrier between past, present, and future. Then there's the fact that white holes are extremely unstable. If they exist at all, they'd be like cosmic firecrackers, brief, bright, and vanishing fast. They might appear out of nowhere, dump their energy, and collapse again, never to be seen in the same form. That means our chance to study one might come only once in a generation, maybe even once in a millennium. We might need entirely new instruments, ones that can detect not just energy, but the fingerprints of time distortion, quantum echoes, or sudden bursts of exotic particles. And if we ever do find one, it would probably raise more questions than it answers. What triggered it? Where did it come from? What laws did it follow, and which ones did it break? Here's another twist. Some scientists believe white holes could leave behind ghost signatures, leftover imprints in spacetime, like bruises on the universe. These imprints might be detectable as tiny anomalies in the cosmic microwave background, the leftover glow from the Big Bang. If we found such a pattern, it could be the smoking gun we've been searching for. It would mean something massive and powerful once tore through our universe and left behind a mark. And if we can map those marks, we might be able to trace a pattern, maybe even build a model of how white holes behave, how often they appear, and what kind of conditions create them. That would bring us one step closer to turning white holes from wild theory into observable reality. Now let's push it even further. If white holes exist, and if they are truly linked to black holes, then we need to think differently about death in the universe. We usually think of black holes as cosmic graveyards, places where stars go to die. But if white holes are their opposite, then maybe every death is a beginning. Maybe every black hole marks the end of something in this universe, and the start of something in another. That flips our whole view of space. It means the universe isn't a closed system, but part of a larger cycle: creation, collapse, and rebirth. White holes would be the sparks of that rebirth, spraying the ashes of old stars into new realms. And white holes challenge our understanding of what's possible. They show us that the universe is still filled with mysteries so deep and strange we can't even measure them yet. They remind us that no matter how much we think we know, there's always more dimensions, more realities, more questions waiting to be asked. White holes sit at the edge of science and imagination. They're not just about physics. They're about wonder. They are the universe's way of telling us, you haven't seen everything yet. Imagine if the atoms that make up your body once fell into a black hole billions of years ago, and then emerged through a white hole, recycled into the matter that eventually formed Earth, the Sun, and everything we see today. If that's true, white holes aren't just theoretical endpoints of cosmic phenomena. They're part of a grand recycling process that connects past, present, and future in ways we can barely comprehend. Now, let's talk about the mathematics behind white holes, because this isn't just science fiction. It's grounded in the same equations that gave birth to the black hole model in the first place. Einstein's field equations and general relativity allow for the existence of white holes as a mirror solution to black holes. If a black hole is defined by a region from which nothing can escape, a white hole is mathematically just the reverse, a region into which nothing can enter. Both are solutions to the same equations, just played in reverse. And this isn't some fringe idea. It's been studied seriously by some of the most respected physicists in the world. But the problem is, just because the math works doesn't mean it happens in reality. The universe is under no obligation to realize every possible solution of Einstein's equations. So, the big question becomes, is there any real mechanism through which white holes could physically form? One idea is that white holes are born when a black hole dies. But black holes don't really die in a normal sense. Over time, they emit Hawking radiation, a theoretical process where black holes slowly lose mass by releasing tiny particles, and eventually shrink down to nothing. But what if they don't just disappear? What if the final stage of a black hole's evaporation triggers a violent, sudden transformation, a bounce? Instead of vanishing, the black hole could rebound, spitting all the trapped matter and energy out at once. That burst would be the white hole. Some researchers call this the black to white hole transition. And it might be one of the rarest but most powerful events in the cosmos. And here's where things get even weirder. If time behaves differently inside a black hole, and many physicists believe it does, then the transformation into a white hole might not take long at all from the inside. From our perspective outside, it might take billions of years for a black hole to evaporate and reach the bounce point. But from the point of view of something inside the black hole, it could happen instantly. That means that in some strange way, white holes might already exist right now, but we're just waiting for time to catch up. It's like watching the slowest video playback of an explosion, stretched across the lifespan of the universe. The white hole is there, it's just in the future, for us. Now, there's also a theory that maybe we've mistaken white holes for something else entirely, something even more mysterious, dark matter. You've probably heard of dark matter before. It's the invisible stuff that makes up most of the matter in the universe, but it doesn't emit light or energy, so we can't see it. We only know it's there because of its gravitational pull. But what if some of this dark matter is actually made up of tiny white holes, primordial remnants from the earliest moments after the Big Bang? They'd be extremely small, almost impossible to detect, and yet still influence the universe through their gravity. These white hole remnants might be scattered everywhere, and if we could prove they exist, we might finally crack the code of what dark matter actually is. And that takes us to one of the biggest debates in theoretical physics today. How do we test any of this? White holes, by their very nature, would be almost impossible to observe directly. They don't last long, they don't interact with other matter the way stars or galaxies do, and they don't emit steady signals like pulsars. But scientists are getting clever. They're looking for specific patterns in cosmic rays, those high-energy particles that strike Earth from deep space. Some of these rays seem too powerful to be explained by normal processes. It's possible, just barely possible, that they could be leftovers from white hole eruptions. In the same way we study fossilized bones to learn about dinosaurs, we might one day study these particles to learn about white holes. The deeper we go, the more it seems that white holes could be central to almost every unsolved mystery in cosmology. They might help explain the nature of time, the fate of black holes, the shape of the multiverse, the origin of the universe, the balance of information, and even the true identity of dark matter. Yet, despite all this, we have no confirmed evidence that a white hole has ever been observed. It's like having a blueprint for a machine so powerful it could rewrite reality, but no one's ever built it. That doesn't stop scientists from trying, though. In labs and universities around the world, teams are running simulations, calculating probabilities, and designing new kinds of telescopes, all in hopes of catching just one glimpse of a real white hole. And maybe the reason we haven't seen one yet isn't because they don't exist, but because we've been looking at the wrong scale. Think about it. What if white holes don't just appear in space, but in time? What if they are events rather than objects, sudden shifts in the structure of reality that unfold across timelines rather than distances? In that sense, the birth of the universe could be a white hole. A sudden, unexplainable release of everything from nothing. Or perhaps white holes are more abstract, like changes in physical laws, or resets in the fabric of space-time. They might be transitions that ripple through the cosmos unseen, leaving only faint traces behind. Picture this. A massive star collapses into a black hole, pulling in light, matter, and time itself. It stays quiet for billions of years, slowly evaporating through Hawking radiation. Then, at the very end, instead of simply fading away, it undergoes a dramatic transformation. Everything it consumed gets ejected outward, not randomly, but possibly in a form and direction encoded by the information it stored. This isn't just speculation. Some models predict this bounce could take place in a flash, while others think it might take trillions of years. Either way, if a white hole is what a black hole becomes, we're not just talking about a strange mirror object, we're talking about a new phase of reality itself. Now imagine what this would mean for the structure of space. Black holes are like tears in the cosmic fabric, pinching everything inward. White holes, on the other hand, could be cosmic geysers, punching outward into surrounding space-time. If such a white hole emerged nearby, it wouldn't quietly appear. It would roar into existence with unimaginable force, creating shockwaves across the galaxy. It could even distort time for nearby observers. Think of how close a supernova can affect its surroundings. Now multiply that by the energy released over the entire lifetime of a black hole, concentrated into one moment. That's the kind of event we're talking about. And that's the kind of event astronomers might already be seeing in the form of brief gamma-ray bursts, strange radio flashes, or other unexplainable sky phenomena. But this theory doesn't just stop with stars. Some physicists have proposed the idea that the entire universe may be inside a black hole. Sounds crazy, right? But mathematically it checks out. If that's true, the Big Bang wasn't the beginning of everything. It was the bounce, the white hole moment following the collapse of a prior universe. That means every black hole in our universe might birth a new universe of its own on the inside, expanding like ours did, but totally disconnected from its parent. This idea is sometimes called cosmological natural selection, where universes give rise to new universes through black hole formation. It's like evolution, but for entire realities. In that case, white holes wouldn't just be fascinating, they'd be fundamental. And what if we could prove this? What if we found a signature, a clue, embedded in cosmic radiation, or some strange symmetry in quantum particles, or even a ripple in spacetime that matched the expected profile of a black hole turning into a white hole? That would change everything. We'd know that the universe isn't just expanding, it's expanding with a memory, with history, with connection to what came before. Every galaxy could be a storybook from another universe. Every black hole, a seed of another cosmos. Every white hole, a rebirth. Of course, we have to be careful. Science isn't about getting carried away with cool ideas. It's about evidence. And right now, direct evidence for white holes is hard to come by. But indirect evidence? That's growing. Take the mysterious fast radio bursts. Those millisecond-long explosions of radio energy that seem to come from deep space, but have no obvious cause. Some are repeating, some aren't. Some appear once and vanish. We've ruled out many natural causes, and though the white hole hypothesis is still very speculative, it offers something the others don't, an explanation for how something so brief and so powerful could exist without any warning or aftermath. It fits the profile of something impossible, because white holes, by their nature, are supposed to be impossible. Yet they might be real. Think about that for a moment. Every black hole, no matter how small or massive, might be a seed. And the seed doesn't just vanish, it might bloom into an entirely new universe. It means that somewhere out there, beyond the event horizon, beyond even what we can imagine, time and space might be unfolding in ways we will never directly experience. But we may be the products of such a process ourselves. We might be living inside the white hole that resulted from a black hole in a universe that no longer exists. Our laws of physics, our constants, even our concept of time, all could be hand-me-downs from a parent universe. That redefines everything about what we think we know about beginnings. Now let's get into what white hole candidates might actually look like to astronomers. If a white hole were to suddenly emerge in space, it wouldn't form gradually. Unlike black holes, which grow from collapsed stars or accumulated matter, a white hole would explode into existence, ejecting all of its contents in an instant, or over a very short time frame. The energy signature would be off the charts. You might see something brighter than a quasar, more violent than a supernova, and shorter-lived than a gamma-ray burst. Some researchers think that fast radio bursts, FRBs, those mysterious, milliseconds-long flashes of energy from deep space, might actually be white holes in action. Because they appear out of nowhere and disappear just as quickly, and because we don't know what causes them yet, they're an intriguing candidate for white hole observation. The problem is, we can't tell if what we're seeing is a white hole unless we know exactly what we're looking for, and we don't. Not yet. Another potential sign of white holes is the hypothetical phenomenon known as Planck stars. These are theoretical objects that form deep within black holes when quantum gravity effects take over and prevent singularities from forming. According to this theory, the immense gravity inside a black hole compresses matter to a point, but then quantum pressure pushes back. The result is a highly compressed Planck-scale object that eventually releases its energy in the form of a white hole. This kind of white hole wouldn't just appear out of nowhere. It would be the final stage of a black hole's life cycle. Over unimaginable spans of time, the black hole would shrink due to Hawking radiation, and finally, when it reaches Planck size, explode in a white hole event. This would be the ultimate act of cosmic recycling, a final burst of all the information and matter it had absorbed, released back into the universe. If that's how it works, then the remnants of ancient black holes from the early universe might be going off like cosmic firecrackers somewhere in the darkness, far beyond our telescope's reach, or maybe just faintly within it. Some scientists believe that the very early universe may have been seeded with primordial black holes, objects formed not from collapsing stars but from quantum fluctuations just moments after the Big Bang. These could be tiny, even microscopic, and they would have long since evaporated if Hawking radiation works as predicted. But if they ended their lives as white holes instead, then somewhere out there might be faint, rare, short-lived explosions that don't fit into any known category of astrophysical event. Detecting them would be like finding the birth cries of hidden universes. Let's also talk about entropy, because this is where white holes really shake up our understanding. The second law of thermodynamics tells us that entropy, or disorder, always increases over time. That's what gives time its arrow. But a white hole, in theory, runs entropy backward. It's not sucking in matter, it's pushing it out. It's not growing, it's dispersing. It's not hidden, it's blindingly visible. This kind of behavior implies a temporal inversion. In some interpretations, it's not just space that flips with a white hole, it's time itself. Imagine watching a film of a black hole in reverse. Instead of light and matter vanishing into darkness, you'd see them violently erupting outward, with perfect symmetry. The concept of time reversal symmetry in physics hints that this isn't entirely absurd. And if white holes are truly time-reverse black holes, then perhaps they exist not in our future, but in our past, maybe the Big Bang itself was one. And that leads to one of the wildest possibilities, that our universe is the interior of a white hole. Not metaphorically, not poetically, literally. Some models suggest that what we experience as cosmic expansion could be the natural result of a white hole ejecting matter. In this model, the edge of our universe, beyond which we cannot see, is the event horizon of a white hole. And beyond that? A parent universe, long gone, whose black hole formed the white hole that became our universe. It's hard to wrap your head around. But it's a model that works with general relativity and quantum theory. In this view, every black hole births a new universe, and every universe exists inside a white hole. It's universes all the way down. This cosmic nesting doll model, universes within universes, brings up serious philosophical questions. If each black hole spawns a new universe, then there could be trillions of universes out there, completely separate from each other. Not just different in content, but different in the very rules they follow. Gravity might work differently. Time might flow in strange directions. There may be no light, or only light. No matter or only matter. We have no idea. And yet, this could be the natural state of reality, an infinite cascade of branching universes, each born from the core of a black hole, each releasing its matter through a white hole. And here's the kicker, if white holes can form naturally, then life could begin not in stars or planets, but in the aftermath of a white hole eruption, in the earliest moments of a brand new cosmos. It also means that the answers to some of the most profound questions we have, like what caused the Big Bang, or where the information swallowed by black holes goes, might all come down to the same thing. If a black hole leads to a white hole, and that white hole creates a new universe, then nothing is ever really lost. It's just transformed. Information isn't destroyed, it's reborn. And if that's true, then we are not simply observers in a dying cosmos. We are part of a living chain of universes, each one giving rise to the next. And somewhere in the sky, hidden in a burst of light too brief to track, might be the spark of the next one forming right now. Even if we never observe a white hole directly, the theory itself reshapes how we see the universe. It gives us a framework to think about time, entropy, gravity, and the ultimate fate of information. It offers answers to paradoxes that have haunted science for decades. And it opens doors to ideas that are stranger than any science fiction story. It tells us that death might not be the end. That collapse might be the beginning. That every end in the cosmos could be the start of something else. That's not just hopeful. That's revolutionary. But it also poses new dangers. If white holes can appear spontaneously, then space isn't as stable as we think. If one were to appear near Earth, the effects would be catastrophic. The energy output could strip away atmospheres, shift planetary orbits, or destroy stars. These are not gentle phenomena. They are violent, unpredictable, and possibly unavoidable. And because we don't know what triggers them, or even if they can appear in our current universe without a black hole precursor, we're left guessing. And that's always a dangerous place for civilization to be in. Yet the pursuit of white holes is one of the most exhilarating frontiers in all of physics. It pulls together relativity, quantum mechanics, thermodynamics, and cosmology. It forces us to rethink beginnings, endings, and the flow of time itself. Somewhere out there, a white hole may be erupting into being right now. And when it does, a new cosmos will bloom, just as ours did long ago. What makes this so fascinating is that Planck stars are not purely speculative. They're built on attempts to reconcile general relativity with quantum mechanics. And that's one of the biggest unsolved problems in modern physics. We've got Einstein's theory of gravity that works on large scales, and quantum theory that works on small scales, but they don't agree with each other. If Planck stars turn out to be real, and if they do indeed lead to white hole emissions, then we might finally be on the verge of connecting those two great pillars of physics. In that case, white holes wouldn't just be exotic objects, they'd be proof that the universe operates on a deeper, more unified level than we've ever known. The discovery of a white hole, or a confirmed Planck star eruption, would be like finding a crack in the wall of the universe, letting us peek into the machinery behind reality itself. Now imagine this. You're looking at a point in space through the most powerful telescope ever built. There's nothing there. Then suddenly, without warning, a brilliant flash erupts, outshining entire galaxies for a fraction of a second. No warning. No build-up. Just a blinding burst of radiation and matter, flung out as if some cosmic dam had just been blown open. Then, just as suddenly, it's gone. No remnant, no neutron star, no black hole left behind. That's what a white hole might look like. An event, not an object. Something that happens rather than something that simply is. And it changes the whole idea of how the universe operates. It means not everything needs a build-up or a backstory. Some things might simply exist for a moment, spill their contents into the cosmos, and vanish forever. The concept of white holes also forces us to think about time differently. In our experience, time flows forward. Causes come before effects. But white holes, in the way they theoretically mirror black holes, flip that around. They suggest a kind of reverse time symmetry. If black holes are where everything goes in, then white holes are where everything comes out. But what if time inside that system doesn't flow like it does out here? What if, from the perspective of the matter inside, entering a black hole feels like going forward in time, and exiting a white hole feels the same? It might mean that what we call the past and the future aren't universal. They might be local experiences, like weather or gravity. And that's mind-blowing because it makes time itself feel fragile, customizable even, depending on where in the universe you are. And there's more. White holes also force us to confront the limitations of our observations. Everything we know about space is built on what we can see, detect, or infer. But what if white holes are so fast, so short-lived, or so far away, that we just keep missing them? Maybe they're happening all the time, but we're just not tuned to the right frequency. Maybe they're outshining everything for a split second while our sensors are focused on something else. It's like trying to catch lightning with a camera that only takes a picture once a day. The event is real, but we're not fast enough to catch it. That's where future observatories, like the Square Kilometre Array or the James Webb Space Telescope's successors, might come into play. They'll be scanning the sky constantly, with the sensitivity needed to catch the briefest cosmic hiccups. And if one of them catches a white hole in action, it's game over for the current model of reality. Now let's entertain a truly wild idea. Some physicists have speculated that white holes could be connected to wormholes. If a black hole acts as one mouth of a wormhole, and a white hole acts as the other, then travel between distant parts of the universe, or even between universes, might be possible. Matter falls into a black hole and emerges instantly from a white hole, somewhere far away. This is the stuff of science fiction, right? But the math doesn't rule it out. Einstein's field equations allow for wormholes. The problem is stability. Wormholes would collapse immediately unless held open by exotic matter, a theoretical substance with negative energy density. We haven't found exotic matter yet, but we haven't proven it can exist either. So if white holes are real, they might not just be endpoints. They might be doorways. This also brings us to Hawking radiation, the process through which black holes are thought to evaporate over time. As they lose mass through radiation, some theories suggest that at the very end of their life, a black hole might transform into a white hole. This last gasp would expel all the matter it once consumed, not in a quiet puff, but in a rapid, high-energy event. And here's where it gets crazy. If this is true, then black holes might not be the eternal prisons we thought they were. Information might not be lost after all. It might just be waiting, trapped in a slow cooker, until the final burst sets it free. This would solve the black hole information paradox. The question of whether information that falls into a black hole is gone forever. And if it's not gone, if it comes back out through a white hole, then we can start to believe that the universe plays fair. That nothing is ever truly lost. But even that idea is controversial. Some physicists believe white holes can't possibly exist because they violate the second law of thermodynamics. If entropy always increases, then a white hole, which appears to reverse that process by decreasing entropy, spitting out ordered matter instead of consuming it, would break one of the most sacred laws in physics. But others argue that if white holes exist in separate regions of spacetime, or inside black holes that form baby universes, then the rules might not apply in the same way. The second law might hold locally, but not universally. Or entropy might still increase if you look at the entire system, black hole plus white hole, as a single entity. This debate is ongoing, and until we get more data, we can only speculate. So what happens next? Scientists are working on it. Theoretical physicists are building models, running simulations, tweaking equations. Astronomers are scanning the skies for signs, any signs, that could point to a white hole. Particle physicists are experimenting with collisions that mimic extreme gravitational fields. Everyone wants the same thing, a glimpse of something new. And that's the core of it, really. White holes represent the possibility that we've barely scratched the surface. That all the laws, equations, and theories we rely on might just be the beginning. And deep down, that's why the idea refuses to die. It's not because white holes have been proven, but because they haven't been disproven. They remain in that tantalizing gray area. The space between what we know and what we dream might be true. It might mean that the universe has hidden pathways where time doesn't flow in a straight line, where events in the past and the future are more entangled than we thought. That's a radical idea, but it's a consequence of the equations that govern black holes and white holes. And when you start thinking this way, the concept of causality, what causes what, starts to break down. If something falls into a black hole in our universe and emerges from a white hole in another, did the cause happen before the effect? Or is it all part of one larger, timeless structure where everything is connected outside of time as we know it? This is where white holes force us to challenge our most basic assumptions, and that's what makes them so mind-blowing. White holes are also fascinating when you start connecting them to the idea of wormholes. Wormholes are these hypothetical tunnels through spacetime, like shortcuts between distant parts of the universe. Some scientists think that a wormhole might connect a black hole to a white hole. On one end, matter is sucked in. On the other, it gets spit out. Now, if that's true, then white holes could be exits to these cosmic tunnels. That would make them more than just theoretical objects. They'd be the endpoints of shortcuts across space and maybe even time. If wormholes exist and are stable, they could make faster-than-light travel possible, at least in theory. And the white hole would be your destination. But of course, there's a catch. Wormholes, if they exist, are probably highly unstable. They might collapse the moment anything tries to pass through. Unless, again, we understand the quantum gravity effects well enough to stabilize them. Another wild possibility is that white holes could be responsible for some of the unexplained energy bursts we've detected in space. Gamma-ray bursts, fast radio bursts, and other high-energy phenomena appear seemingly out of nowhere. Some last only milliseconds. Others go on for minutes. We still don't fully understand what causes all of them. Could it be that a few of these events are actually white holes in action? Cosmic pressure valves that suddenly release matter and radiation that had been trapped for eons inside black holes? It's speculative, yes, but it fits with the idea of energy and matter being conserved, just redistributed in ways we're only beginning to understand. Now, let's go deeper into the implications. If white holes exist, they challenge the idea of information loss in black holes. This is one of the most intense debates in modern physics. According to classical theory, anything that falls into a black hole is lost forever. But quantum mechanics says information can't just disappear. That would violate the core of quantum theory. So where does it go? Some physicists believe that information is somehow encoded on the event horizon. Others think it escapes through something called Hawking radiation. But if black holes are connected to white holes, then maybe that's where the information goes. Into a white hole that eventually releases it back into the universe in a different place or time. That would preserve quantum information and solve a mystery that has stumped even the greatest minds. And this leads us into something even crazier, the idea of a universe within a black hole. Some cosmologists propose that every black hole might be a doorway to a new universe. If true, then what we think of as the singularity inside a black hole isn't a point of infinite density, but a bridge to another expanding reality. In that scenario, a white hole might be the big bang of that new universe. It might explain why the laws of physics in our universe seem so finely tuned, because we're inside a white hole that formed from the collapse of a black hole in a parent universe. This concept is called cosmological natural selection, and while it's highly theoretical, it offers an elegant way to explain both the origin of our universe and the mechanism behind white holes. You also have to consider what this means for multiverse theories. If white holes can spawn new universes, then our universe might be just one bubble in an infinite foam of universes, each one beginning as a white hole from a black hole in another. And if that's true, then the structure of the cosmos is far bigger, far stranger, and far more interconnected than we ever imagined. It's not just stars and galaxies and dark matter. It's an endless chain of realities, each birthing the next through a cycle of collapse and rebirth. White holes would be the seeds of cosmic regeneration. Another point to think about is how white holes relate to the early universe. After the Big Bang, our universe went through a period of inflation, a rapid expansion that spread matter across the cosmos in an instant. Some theorists suggest that this inflationary phase could have been driven by white hole-like dynamics. In other words, the Big Bang itself might have been a white hole event. That means our universe isn't just a random explosion, it's the result of a process that started in another universe, through another black hole, possibly in a completely different set of dimensions. It's a powerful way to look at our origin, not as a beginning from nothing, but as a transformation from something else. But here's something else to blow your mind. What if white holes aren't just out there, in space? What if they exist on smaller scales too? Some physicists have theorized that tiny white holes could exist as relics from the early universe. These would be microscopic, but still incredibly powerful. If any of them still exist today, they might occasionally erupt, releasing bursts of radiation. And if we ever detect one of those microbursts, it could be the first direct evidence of a white hole. We're talking about particles or energy bursts that don't fit any known explanation, something totally new, totally outside current models. That's why experimental astrophysicists are always on the lookout for anomalies, for the kinds of signals that don't make sense. Because it's in those moments of confusion that new physics is born. White holes might also help solve the mystery of dark energy, the force that's causing the universe to expand faster and faster. We still don't know what dark energy is, or why it behaves the way it does. But if white holes are constantly releasing energy into the cosmos, especially if they're tied to black holes in other universes, it could mean that our universe is being slowly infused with energy from outside. That would help explain the acceleration we see today. And it would mean that the cosmos is even more open and dynamic than we thought. Not a closed system, but one that breathes energy across dimensions. Even time itself might not be what we think. If white holes exist, they hint that time might have different rules depending on where you are in the universe. Maybe time isn't just a straight arrow, but a loop, or a web, or something else entirely. Maybe things that fall into black holes don't just vanish, they go somewhere else where time moves in reverse or sideways or spirals outward. That changes how we think about fate, causality, and the meaning of time itself. It makes everything more mysterious, more unpredictable, and more open to discovery. If white holes actually exist, then the very nature of reality might be far more bizarre than we ever imagined. See, the thing about white holes is they challenge our fundamental understanding of space, time, and information. According to classical general relativity, once something crosses the event horizon of a black hole, it's gone, forever trapped in a region of space from which not even light can escape. But quantum mechanics has a big issue with that. It says information can't be destroyed. And that leads us to one of the biggest problems in modern physics, the black hole information paradox. Some physicists have proposed that white holes might be the answer. Maybe black holes don't truly destroy the information that falls into them. Maybe, after a long enough time, they evolve into white holes and release that information back into the universe, not as recognizable objects, but as encoded bursts of radiation or particles. Let's pause here and think about what that means. If information can reemerge from a white hole, even in a scrambled form, then the entire life cycle of a black hole could actually be part of a bigger story about the universe trying to preserve the integrity of everything that's ever happened. Nothing is ever really lost. Just transformed. But the real kicker? This idea suggests that white holes aren't just theoretical. They're necessary. They're a part of the balance. For every black hole that consumes, there could be a corresponding white hole that gives back. Theoretical physicist Carlo Rovelli has taken this idea even further. Along with his team, he's explored a concept where black holes don't end in a singularity, a point of infinite density, but instead bounce when quantum gravity kicks in. After billions of years, the black hole turns into a white hole and starts releasing everything it once swallowed. This bounce would mean the matter never really disappears. It just takes an incredibly long journey through an ultra-compressed state before being spit out again. It would be like a cosmic recycling process operating on mind-bending timescales. And if Rovelli is right, then the universe isn't just filled with things that collapse, it's also filled with rebirths. That opens up a huge question. How would we even recognize a white hole? What would we see? The problem is, they'd be hard to spot. Unlike black holes, which reveal themselves through the intense gravity they exert on nearby stars or matter, white holes would repel matter. They wouldn't have accretion disks or jets of radiation spiraling around them. Instead, they'd likely appear as sudden, intense flashes of energy in parts of space that seem otherwise empty. And that brings us back to fast radio bursts, those brief and powerful signals we've detected from distant galaxies. Some researchers have suggested these bursts might be caused by white holes, essentially brief explosions of matter and energy that had been trapped in a black hole for billions of years and finally had nowhere else to go but out. It's also possible that some of the empty regions of the cosmos aren't so empty after all. They might be hiding dormant white holes, cosmic time capsules waiting to activate. Maybe they only wake up under very specific conditions. Or maybe they've been active all along, but we don't yet know how to recognize their signatures. That means every time we point our telescopes into the deep void and pick up something strange, something that doesn't match any known object or pattern, we might be catching a glimpse of a white hole doing its thing. But the questions don't stop there. If white holes exist, are they born at the same time as black holes? Do they require a certain amount of time to form, or is the process instantaneous? Are they rare cosmic events, or is the universe full of them, hidden among the stars, waiting to be discovered? And perhaps most puzzling of all, if something were to emerge from a white hole, where did it come from? If it was inside a black hole, did it travel across space, time, or even dimensions to reach us? Some radical theories suggest that white holes could connect to other universes entirely. Think about that. Every black hole in our universe might be a portal not just to a white hole in our own cosmos, but to one in a completely different universe with its own laws of physics, its own history, its own stars and galaxies. That would mean our universe is just one of many, a single node in a vast multiversal web connected by tunnels of collapsed and exploding space-time. This isn't just science fiction, it's rooted in real, serious physics that tries to bridge the gap between general relativity and quantum mechanics. And then there's time. White holes might not just be spatial phenomena, but temporal ones. In other words, they might run backward in time compared to black holes. While black holes pull matter into the future, white holes might push it into the past. That's wild. It suggests a kind of symmetry in the universe, a mirror image structure where every destructive force is balanced by a creative one. This symmetry could help us finally understand what time really is, not just the direction things move in, but a dimension that can be bent, reversed, or mirrored in ways we don't yet understand. One of the most bizarre implications of white holes is that they could allow for closed time-like curves, loops in time where an event could be both cause and effect. That's the kind of thing that leads to time travel paradoxes, like going back in time and preventing your own birth. But in physics, these loops aren't just theoretical nightmares, they're possible solutions to Einstein's field equations. And if white holes are real, they might be the gateways to these loops. So now let's talk about something truly strange. What if our universe began as a white hole? Some cosmologists have floated the idea that the Big Bang itself could be the result of a white hole explosion, one that expelled all the matter and energy we now see as galaxies, stars, and planets. That would mean the Big Bang wasn't a singularity from nothing, but a bounce from something else, a collapsing universe that turned inside out and became our own. If that's true, then we're living inside the product of a white hole right now. Everything we know, everything we are, is the aftermath of a colossal event that might have had its roots in a different reality entirely. But this leads to even deeper ideas. If the Big Bang was a white hole, where was the black hole that fed into it? Did it exist in a parent universe? Was it part of an eternal cycle of births and deaths, black holes collapsing and white holes exploding, over and over again forever? That's the ultimate cosmic question. If white holes are real, then they might be the key to understanding not just black holes, not just space and time, but everything, the origin, structure, and fate of the entire cosmos. Matter and the radiation emitted by infalling debris, white holes would be the opposite. They'd repel matter, not attract it. That means they wouldn't have glowing disks of gas spiraling into them, no extreme X-ray flares, no gravitational tugging of stars in their vicinity. Instead, a white hole might appear as a sudden, inexplicable burst of energy, or particles coming seemingly from nowhere, an eruption without a cause. And believe it or not, some scientists think we've already seen hints of them. Fast radio bursts, or FRBs, are one such hint. These are insanely powerful flashes of radio waves that last only milliseconds but release more energy than our sun does in a day. Nobody really knows what causes them. Some believe they come from magnetars, extremely magnetic neutron stars, but others think that they could be signs of white holes briefly blinking into existence. Imagine a cosmic valve suddenly opening for a split second, releasing energy that had been trapped for eons. That's the kind of outburst we're talking about. Another clue could be hidden in gamma ray bursts. These are the most energetic explosions we've ever observed, and while most are thought to be tied to supernovae or neutron star collisions, a few remain unexplained. If a white hole suddenly activated in deep space, especially one that had been a black hole for billions of years, the energy release could be cataclysmic. But we wouldn't see it building up. There would be no warning. It would just happen. Now think about this. If the universe contains even a handful of white holes, then it means space-time itself is not static. It has memory. It holds onto the history of every atom, every photon, every bit of matter and energy swallowed by black holes and may eventually return them, scrambled, yes, but not lost. This changes everything. It means the universe may have mechanisms for restoring balance, not just consuming and collapsing, but giving and creating. And what if, in the farthest reaches of space, some of these white holes aren't just random eruptions? What if they're organized? What if they're relics of civilizations far more advanced than us, who learn how to manipulate black holes and harness their transformation into white holes? It sounds insane, right? But some theoretical models suggest that if you could control the environment around a black hole, feeding it, cooling it, shaping the quantum fields, you might actually accelerate or guide that transformation. In other words, white holes could be artificial. Now, this is obviously deep into the realm of speculation, but in a universe this strange, we can't rule it out. Especially when we still don't understand most of what's out there. Dark matter, dark energy, wormholes, the quantum foam of space-time, these are all signs that the universe is far weirder than our best theories can currently explain. And white holes sit right in that uncomfortable space between what we think we know and what might be possible. What really messes with the mind is this: some cosmologists think our universe itself might be the inside of a white hole. That's right. Not just that white holes exist somewhere out there, but that the Big Bang itself might have been the result of a white hole releasing its contents into what became our reality. In this view, a collapsing star in another universe formed a black hole, and everything inside it was squeezed into a singularity, until it rebounded and exploded into our Big Bang. That would make our universe a baby universe birthed from a larger one. A multiverse parent-child relationship. And that's a concept so big, it forces you to question everything about our origin. And here's where it gets even deeper. If the universe is a white hole, then time itself might be moving in a very specific direction, not just because entropy is increasing, but because we're literally moving outward from a singular release point. Space and time are expanding not randomly, but as part of a directional, intentional flow. That would mean the arrow of time isn't just a thermodynamic quirk, it's built into the very structure of our cosmic origin. Now you're probably wondering, how close are we to proving any of this? Honestly? Not very close. White holes are still entirely theoretical. We've never directly observed one. There's no confirmed candidate that scientists universally agree on. But that doesn't mean the idea isn't gaining ground. More and more researchers are exploring the equations, the possible observations, the indirect effects. And with telescopes like the James Webb Space Telescope and future gravitational wave detectors, we might finally start to see anomalies that can't be explained by anything else. Until then, white holes remain one of the most powerful reminders that the universe is far from figured out. That we're still in the earliest stages of understanding what space and time really are. That every mystery we solve just opens the door to more questions. And that, somewhere in the darkness, the universe might be hiding entire worlds, entire histories, waiting to burst forth in a cosmic exhale we've never seen before. If you could control the environment around a black hole, feeding it certain forms of matter, controlling the rate at which it accretes mass, or influencing the spin and charge, it might be possible to manipulate the timeline of when or even if it becomes a white hole. Imagine a civilization advanced enough to see black holes not as destructive dead ends but as cosmic batteries or portals. They could create white holes as controlled energy sources or even information-releasing hubs, selectively deciding when to extract the data locked inside the black hole. This would be technology that operates on a scale far beyond our understanding, civilizations that could engineer space-time itself, bending the laws of physics to their will. To them, a white hole wouldn't be a mystery, it would be a tool. And that makes you wonder, what if some of the unexplained bursts of energy we detect are not accidents of nature, but signals? What if these white hole eruptions are not just spontaneous cosmological events, but intentional? They might be beacons, messages, or even delivery systems carrying information across impossible distances and unimaginable stretches of time. Perhaps the reason we don't understand some of the weirdest space signals, why they appear suddenly, without warning, and never repeat, is because they're not meant to repeat. They've served their purpose. They arrived. We just haven't figured out how to read them yet. This takes us to the heart of the information paradox. When something falls into a black hole, what happens to the information about it? For a long time, we thought it was lost forever. But then came Hawking radiation, the idea that black holes slowly evaporate over time. If black holes can leak energy back into space, then maybe they can leak information too. But that creates another problem. How? Information can't be destroyed. That's one of the fundamental rules of quantum mechanics. And if it isn't destroyed, then it has to go somewhere. Enter white holes. Maybe they are the answer, cosmic safes that open after millennia, spitting out all the secrets of what was once consumed. Think about that for a second. If white holes exist, then no particle, no wave, no moment in time is ever truly gone. Everything that's ever fallen into a black hole, every collapsed star, every fragment of light, maybe even traces of alien technology or intelligence, could one day emerge, altered and ancient, but not erased. That would make the universe not just a place of destruction, but of recovery and renewal. Black holes would be like memory banks, and white holes their playback devices. But instead of returning things instantly, the universe makes us wait. It forces us to reckon with time on the longest scales imaginable. And yet, this theory also opens terrifying possibilities. If black holes store and white holes release, then the contents of the most violent regions of the universe are still out there, waiting. Waiting for the right moment, the right conditions, to explode back into reality. What if a white hole suddenly formed nearby? What if all the mass and energy it unleashed came barreling into our part of the galaxy? It wouldn't be like a supernova. It would be something far more chaotic, unpredictable, and unstoppable. The blast could bend space, disrupt orbits, tear apart planets, or even mess with the fabric of reality itself. We wouldn't be able to prepare for it. We might not even see it coming until it's too late. But then there's the quieter, more philosophical angle. Maybe white holes aren't explosive. Maybe they don't come back with a bang but with a whisper. A low, subtle change in the structure of space. A slow bleeding of mass and data into the void. In that case, they might be all around us, happening constantly, just too subtle for us to detect. We might already be living in the afterglow of ancient white holes, basking in the diluted remains of entire galaxies that collapsed and returned before our sun was even born. The universe could be full of white hole relics, places where space is thinner, time flows differently, or matter behaves strangely. If that's true, then some of the anomalies we see, galaxies with odd shapes, stars that behave in unexpected ways, dark patches of sky where no light escapes but no mass is detected either, could be the fingerprints of past white holes. We've just never looked at them with that lens. We keep trying to fit everything into what we already understand, but white holes demand that we stretch beyond that. They challenge our basic assumptions about time, gravity, and reality itself. They force us to imagine a universe where endings aren't final and destruction is just the first part of the story. And then there's the idea that white holes could be older than the universe itself. That's right. Some models propose that what we call the Big Bang might have been a white hole. Not just any white hole, but the final moment of a black hole from a different universe. This is part of a theory called conformal cyclic cosmology, and it's as wild as it sounds. In this idea, the universe goes through infinite cycles. Each universe lives, expands, decays, and ends in a collection of massive black holes. And eventually, those black holes explode into white holes, which become the seeds for the next universe. If that's true, then we're living inside a white hole right now, inside the aftershock of a previous cosmos that collapsed long ago. This flips everything on its head. It means our universe isn't the beginning. It's a continuation. A rebound. And it implies that white holes aren't rare or exotic, they're necessary. They are built into the architecture of existence, like the hinges on a door that never stops opening and closing. They are the mechanism by which the universe recycles itself, ensuring that nothing is ever truly lost, only transformed. And that means our entire understanding of time, death, and reality is incomplete. We think in terms of beginnings and endings, but maybe there are only transitions. Maybe the universe is one long, continuous breath, in and out, black holes inhaling, white holes exhaling. Of course, none of this is proven. White holes remain hypothetical. But the math works. The logic works. And the pieces are starting to line up. The more we learn about black holes, quantum mechanics, and information theory, the more it seems like white holes might not just be possible, they might be inevitable. The universe may demand their existence, simply to balance the books. Because in a cosmos as vast, as intricate, and as law-abiding as ours, things don't just disappear. They change form. They reappear. And they surprise us. And if that's true, then we're in for the ride of a lifetime. Because as our telescopes get better, our sensors get sharper, and our theories get deeper, we might be on the verge of detecting the first true white hole. Not a hint. Not a maybe. But a confirmed case. And when that happens, it'll be more than a discovery, it'll be a revelation. A sign that the universe still has secrets to show us. A reminder that we know so little. And a promise that reality is stranger, more mysterious, and far more beautiful than we ever imagined. This video is for educational or entertainment purposes only, and information provided in the video may be incorrect. Like the video and subscribe to the channel for more such amazing videos.